changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged.
Hello, good morning everybody. Welcome to the online EU PVSEC conference of 2021. We have delegates and presenters from every corner of the world, and many of you are working through the night. Indeed, even one of our presenters this morning is coming from the US and is working through the night tonight. So thanks everybody for connecting. We have a very exciting technical program this week, and we will continue to accelerate the progress to make PV the #1 energy source of the future. New this year, we have some topical interactive panel discussions. We've got one every day of the week from Monday to Thursday, and the first session after lunch. So please make sure you check them out. They're very, very interesting. Now, also, I'd like to remind you to make sure you get the maximum out of our networking capabilities through the conference this week. Obviously, an online conference, It's a little bit more difficult to network than in a physical conference, so we've got a range of tools available. So please check out your user area, and you can indicate your topics of interest so people can find you more easily. And also you can upload a short curriculum as well, so people have a little bit more idea of your background. And if you're like me and you are finding it easy to remember faces but have a terrible memory for names, please also upload a photograph as well and help make yourself identifiable to everybody else. So now after that, I just hand you over to our general chair, Joao Serra, who will also say a few words before we start the first plenary of this morning. Okay, thank you, Joao.
Yeah. Thanks, Robert. Good morning, everybody, wherever you are, day and night, like Robert said. Well, Robert told you about the technical program, but let me also call your attention to the great opening session we will have this morning with highly distinguished guests on the political level. We will have also the Becquerel Prize ceremony and the panel discussion about a hot topic today in Europe, PV manufacturing coming back to Europe. So please stay tuned. We will start now by the first set of plenary contributions, in this case under the overall theme Devices in Evolution, Pushing the Efficiency Limits and Broadening the Technology Portfolio. This session will be shared by Wim Sinke from TNO Netherlands and Robert Kenny from the Joint Research Center. Wim, I'll pass to you now.
Thank you, Joao and Robert. And good morning, dear PV colleagues. Welcome to this opening session of the 2021 European Photovoltaics Solar Energy Conference. Over the years, this opening session has always provided a deep dive for a broad audience into an important hot topic in photovoltaic science and technology. This year is no different, and the topic that was selected, it was just mentioned by Joao, is devices in evolution. And to explicit that a little bit more, pushing the efficiency limits, but also broadening the technology portfolio. It covers a broad range of topics, as you will find out in the coming hour. And I'm really pleased to introduce the first speaker to you, who is Dr. Mathieu Bocard, who chose a very nice and ambitious title for his presentation, Perfecting Silicon. Dr. Bocard leads the silicon heterojunction activities at the PV lab of EPFL in Neuchâtel in Switzerland. And he graduated from École Polytechnique in Paris. And he received his PhD from EPFL for his work on thin film silicon solar cells. Moreover, he was a postdoc at Arizona State University working on crystalline silicon, cadmium telluride, and perovskite silicon tandem solar cells. So clearly, he is not just a person with a deep knowledge, but also a very broad knowledge of PV technology. And we really welcome him to the virtual stage. Mathieu.
Thank you, Wim, for the nice introduction, and thank you to the organizer for giving me this opportunity to present and to be the first speaker, which is, of course, always a challenge also. And indeed, also the title will be another challenge, Perfecting Silicon. So I will try to give you an overview of what can be done on that aspect and fresh results about that. But first, why do we need to perfect silicon? Because it's a very relevant material, very relevant technology for the photovoltaic market. And we can see that it's always been dominating. So we see it from this graph from the front of her. From early days to now, 95% of production comes from crystalline silicon. And it doesn't seem that it's slowing down. It seems that it's keeping its pace. What we do see different from the early days, let's say before 2015, however, is that there is a massive shift towards high efficiency product. And we see it first here by the big share that is taken by monocrystalline silicon compared to multicrystalline silicon. And that means that indeed we need to improve efficiency to stay competitive. If we look a bit at the history evolution of efficiencies of crystalline silicon modules, So it's the average sold module on the market, depending on the year. We see that the efficiency is increasing, and it's increasing even faster in recent years. There are different reasons to that, but typically a switch of contacting technology from traditional aluminum back-surface fill to PERC, the adoption of multi-bus bar, half-cell, larger area modules compared to before, and the trend is really for higher efficiency concepts. And we see that it's supposed or predicted to continue, and notably through the adoption of the passivating contacts. Talking about passivating contacts, let's look first at what a standard solar cell on the market is made of nowadays. And that would be a PERC solar cell. And we can see in this sketch that it has contacts on each side, which are directly touching the crystalline silicon wafer. So that's a big limitation towards the efficiency. And we see on this graph that compared to what would be an ideal solar cell efficiency, which of course cannot be reached in real life, but would be the ultimate limit around 29.5%. The best PERC cell that was industrially compatibly made so far, based on the efficiency tables for Martin Green and co-workers, only reaches a quite low open circuit voltage. The main advantage, though, is that it has only a diffused silicon to form the contact on the front side, and a silicon nitride layer as anti-reflective coating. So no absorbing layer before the light touches the wafer. So that gives a very decent high current, still far from the ultimate limit though. But if we consider that we have imperfect anti-reflection coating and grid shadowing from any industrial solar cell, we are getting quite close to what can be done. What can we further do with this technology? Well, we can play a little bit with the area here of the metal silicon contact. We can play a little bit with the doping of this diffused junction, but overall this will be limited. And even though 25% cells were made by the team of Martin Green and USW already a few years ago, it seems that its potential industrially is limited to about 24%. So we would already be there. Now, what we can do further is exactly these passivating contacts. And here are the two main technologies adopting these passivating contacts. One is the TOPCon, which introduces on the backside a doped polysilicon layer, and a tunnel silicon oxide layer, which passivates and screens the silicon wafer from the metallic contact. And the other one is the silicon heterojunction. And in that case, we have thin amorphous silicon layers on each side of the wafer, plus typically a transparent conducting oxide, usually ITO, indium tin oxide, and that separate these metal contacts from the silicon wafer. So by separating the metal contact from the silicon wafer, we get a boost of open circuit voltage. In the case of the TOPCon, only moderate, because the front side still has a direct metal contact. But in the case of the heterojunction, we do get almost the ideal voltage that we could hope for a silicon device. So this gets pretty good. The drawback is that the current in the latter case, in the silicon heterojunction, is significantly lower. And that is due to the presence of these amorphous silicon and indium tin oxide layers before light enters the silicon wafer. But what could we do if we dream a bit? If we try to perfect silicon, then we could imagine that we get the same transparency as the best-in-class devices, but still the best voltage we can hope for. And in that case, we almost touch this 27% line. And what it would require is a transparent passivating front contact. So that's one of the holy grail, let's say, of research nowadays. Of course, we don't have to restrict ourselves to silicon. And if we look at other materials like metal oxides, they can be much more transparent than silicon. And people have tried in recent years quite intensely to adopt other materials. And typically, this is the first efficient silicon cell made with dopant-free contacts in 2016, almost reaching 20%, and using a stack of molybdenum oxide and a TC on the front and lithium fluoride aluminum on the back. Now, since then, efficiency is improved, and if we look only on the front side, using molybdenum oxide, 23.5% efficiency were achieved. If we use two-side dopant-free doped silicon-free contacts, we can reach a moderate 21%. If we go IBC, we get 22%. But overall, these results are still lower than the devices using doped silicon as contacts. There is still amorphous silicon that is used, and for the electron contacts case, they are only used on the rear side, typically grouped with a lower function metal like aluminium. And typically this reference explains a little bit why. But if we try to dig in the literature and fundamental material properties, if we take basically any wide bandgap or moderate bandgap material, and I took this graph from Van de Walle et al. From 2003, the level where hydrogen or the level created by hydrogen in the material will lie here around 4.5 eV from the vacuum level. And if we compare that to the bandgap of silicon, it lies pretty much mid-gap of silicon. So that if we have a material which is non-doped and we add a bit of hydrogen, its Fermi level will be pretty much in the middle of the silicon, so it will neither be a good electron contact nor a good hole contact. And same goes for typically nitrides, as was shown by Walukiewicz a few years later. And a recent paper where we wrote deals a bit with that also, but stay tuned for more info. Now, if we think about that we need something that is doped as a contact, there was recent work on nanocrystalline silicon carbide from the Jülich group in Jülich, and they managed to get a really low work function, wide bandgap, and high doping nanocrystalline silicon carbide layers. And we can see that by tuning the deposition process, they managed to increase the bandgap, so lower the absorption coefficient, and at the same time increase the conductivity. So if we compare to amorphous silicon, which is the classic silicon heterojunction contact, we see that this nanocrystalline silicon carbide layer is way less absorbing in the visible part and still quite conducting. With that concept, they reached a passivating contact solar cell with two-side passivating contacts, with the electron contact on the front side combined with an ITO, and an efficiency of 24%. And most importantly, I would say the front side uses this nanocrystalline silicon carbide stack, a silicon oxide passivation layer and ITO, but reaches current density close to the homojunction configuration. So we are, let's say, closing the gap with diffuse junction. Now, if we talk a bit more about silicon heterojunction and what happened in recent years, I would say that a big evolution was that the intrinsic amorphous silicon passivation layer was improved, and it started already 10 or 20 years ago, but in recent years, and typically since 2017, the microstructure ratio, so the porosity, hydrogen richness of the layer was shown to be a critical parameter, and that high fill factors could be gained by adopting adequate deposition conditions. And this was really pioneered in 2017, but other papers followed, and this was key to enable a 25.1% efficient device by Hanergy a few years ago. I think it's the Roux paper here. Now, if we look at another aspect, was to replace the doped amorphous silicon by more transparent alternatives. And typically what's quite trendy these days is the nanocrystalline silicon oxide alloys. The advantage was already shown on thin film silicon devices. And here I know well about this work because I was actually part of the team back then working on this technology. We see that if we look at the external quantum efficiency, the the nanocrystalline layers are absorbing quite substantially in the blue part of the spectrum, but the nanocrystalline silicon oxide unable to get more light into the solar cell. This was very beneficial from thin film silicon, but it took a few years to be adopted in heterojunction. And I think works from Mazzarella from Helmholtz-Zentrum Berlin was quite pioneer on that aspect. And here the gain in current with the dashed gray line compared to the black line was obvious, but it was also introducing series resistance when adding oxide in the p-type contact. However, a few years later, this was also used in the Hanergy high-efficiency device. On our side, what we did is also work on that topic, but it's a very, let's say, tedious effort to optimize all aspects, and typically to manage to get a good passivation, high transparency, and good contact. We here adopted a very numerous multi-layer stack with first the passivation layer, a small silicon oxide nucleation treatment to have high nanocrystallinity, and a tri-layer stack for the nanocrystalline silicon oxide layer. Other approaches like high mobility, transparent conducting oxide, a double layer anti-reflection coating. On the backside, also a dielectric layer to mitigate plasmonic absorption. But overall, we could manage to get a high efficiency device with a whole selective contact on the front side, up to 24.4%, and using this nanocrystalline silicon oxide approach. Now, using nanocrystalline silicon layers, we can also go IBC, and that's what was shown, pioneered in EPFL and CSEM a few years ago, shown in this Nature Energy paper from 2017, and taken over by CSEM then more intensely, and they could demonstrate 25% efficiency with a very simple process using tunneling of electron and holes between P and N stack of nanocrystalline silicon, and a single mask and single patterning step. Now, this is adopted also at larger area by Meyerberger here in Neuchâtel, and they recently demonstrated an indium-free device with 25.35% efficiency on a large area, so above 200 square centimeter. So this is really an effort that is worth continuing. But since we talk about making the layers more transparent, how about localizing them? And here I make a little sketch of what we could do if we decide to only have the doped silicon layer under the contact. We could also even have a little bit of ITO under the metal contact, but have most of the area simply covered by an anti-reflecting coating. And if we look at the share of losses in our 24.4% device, we realize that the contact resistance here to extract holes from the front side is only a minimal share, whereas the absorption of the window layer, the absorption of the P nanocrystalline silicon ITO stack is still a big share. So simply by assuming that if we reduce the area covered, we can reduce this share, but of course increase the contact resistance share, we end up with such an optimum, and it looks like 40% of coverage area would be the optimal. If we make a bit more sturdy simulations, still being analytical, but accounting for the fact that holes or electrons can travel in the wafer or in the TCO, that there is a contact resistance at this interface and again at the TCO to metal interface, we can see how the efficiency moves or changes when we start to localize more and more the contacts. And depending on whether we have a hole contact or an electron contact, the story is not exactly the same. For holes, since hole conductivity of the wafer is limited, we get a little bit of gain, but then a sharp drop. Whereas for electrons, since the conductivity is larger, we can get a bigger gain even for quite large areas which are non-contacted. But in both cases, a low contact resistance is critical, and that was also discussed a lot in this recent paper. Now, if we look at a proof of concept, here in that case, we either used a front junction or rear junction and either used p-type amorphous silicon, nanocrystalline silicon, or n-type nanocrystalline silicon. And we had different patterning shapes to have a variation of the ITO width here to contact the solar cell. And depending on the fraction of contact, open circuit voltage stays the same. Of course, when we diminish the area covered with ITO, in the case of the p-type amorphous silicon, we have a drop of fill factor. That's because contact resistance is not very good. But for the other cases, we maintain a pretty decent fill factor and a pretty decent series resistance, which confirms that indeed this is possible. In this proof of concept, current decreases because we didn't have any additional anti-reflection coating. Now, if we look at our best device using both N-layer and ITO localized, with an additional anti-reflection coating, we could reach close to 22% with only 50% of the area contacted on the front side. So the long-lived myth that silicon heterojunction need an ITO layer maybe has to be thought of again and to be revisited, especially with the emergence of very low contact resistance material. Another work I want to mention here, again by the Jülich group, is by Li et al. And just came out this year. And in that case, they pushed it a bit further. There is absolutely no ITO on the front side, just a silicon nitride layer and a metal directly in contact with the amorphous silicon layers. And in that case, they can get a decent boost of external quantum efficiency thanks to the only presence of silicon nitride, but there is still the doped layers on the whole area which need to be, which create a parasitic absorption. That brings me to the conclusion. And I mentioned briefly first that high efficiency silicon technologies are set to lead the market, that passivating contacts are limited to about 25.3% in their current forms. Strategies include either to go IBC, that works, but it needs patterning and engineering. Localizing the contacts seems also a bit tedious in that aspect, and finding alternative materials also needs some material development, and that can be quite long. But there are lots of materials available here out. With that, I would like to thank my coworkers as well as my funding agency for funding. And thank all of you for your attention, if anybody at all is listening.
Thank you, Mr. Bokar. Great presentation, and thank you for giving this outlook on what is still to come in silicon technology. I think we don't have a lot of time for questions. I saw one coming in, and I would like to ask you to use the question tool for that and not the chat. But I could not really appreciate the question in the sense that it was connected to a specific slide that you showed, but I forgot which one. So it was about the much lower VOC in a specific case. But I guess I would like to use the very small time or a short time that we have left to ask you just one question. So you said that the average efficiency of modules today is over 20%. How long do you think it will take until the average efficiency is, say, 24% for silicon, taking everything that you discussed into it? Will we see modules like that, and how long will it take?
It's always difficult to predict the future, but yes. I would like to say that we will see some 24% module. I'm quite convinced about that. Whether there will be mainstream and average efficiency, I'm not sure. Maybe there will be premium products, but above 23%, I think will be definitely mainstream product in 5-10 years.
Okay.
So 23-24% range, I would say, thanks to the adoption of passivating contacts and further module work on the module side.
Yeah. Thank you very much. That is really a great perspective for silicon technology. So with that, I would like to hand over to Robert Kenny for the second presentation. Thank you again.
Thank you, Graham. Thanks a lot. And thanks to Matthew for that great presentation. I can confirm from from the technical side that we do have an audience numbering in the several hundreds, so you can be sure that you've had a good audience listening to your presentation this morning. So now I'd like to introduce the next presentation, which is going to be given by Robbie Pijpst. He's a physicist by training, and he's currently the head of a research group on emerging solar cells at ISFH in Germany. And the title of his presentation is Beyond Single Junction Efficiency. So now we've just heard where the first speaker thinks that single junction crystalline is going to end up, and now we're going to hear a perspective on what could be coming next after that. So Robbie, I'll hand the floor over to you. Thank you.
Okay. So thanks a lot for this very kind introduction, and good morning everybody from my side, and welcome to my talk. I first would like to thank the organizers for inviting me to give this plenary talk, which is a great honor not only for myself but also for the entire team, which you can see here in this photograph. And I have to admit that I have changed the title a bit to Exploiting Single Junction Efficiency Potentials and Going Beyond, because I also would like to spend some words on single junction concepts as well. And as an introduction, I would like to draw your attention first to a totally different research field. And at least for me, one of the most impressive recent scientific achievements was the fast development of different vaccines against COVID-19. And there's an excellent documentary from Catherine Gale and co-workers on this topic. And it was really remarkable that it was possible to accelerate the development of such a vaccine from normally more than 10 years down to less than 1 year from the first publication of the DNA sequence to the first approval of one vaccine. And of course, I don't want to directly compare this work to our work in PV, because I clearly acknowledge that those are different fields, and also the COVID-19 vaccines already saved the lives of millions of people worldwide. Nevertheless, it might be allowed to ask whether there's something we can learn from this success story for our field, because as you all know, the mitigation of global warming and therefore the further deployment of renewable energy, such as photovoltaics, is also important. And I found at least two aspects in this documentary which might be transferable in some way to our field. And the first one was that for the vaccine development, very different concepts have been evaluated in parallel. And eventually, not only one, but multiple of them turned out to be viable. And also, the production is shared worldwide in order to provide sufficient amount of vaccine to the world population. And this can hopefully also be transferred to PV. We also have a diversity in our technology approaches, and it would be probably also valuable to share production worldwide. And the second aspect I found interesting was the statement from Bernie Graham from the National Institute of Health in the US. And he said that a 30% efficient vaccine saves more life than an 80% efficient vaccine when it's applied 4 months earlier. And a possible translation to PV could be that it's really important to look on different time scales. So it's really valuable to work on tandem cells with a very high efficiency potential in the future, but it's also important to push the deployment of PV with techniques which are already mature now. And of course, you may ask whether these lessons learned are really transferable to our field, because not only the context is different, but also the subject of research, in our case, solar cells, are much simpler system than the human body. So it might be possible to predict the best technology a priori and to skip all other development paths. But one of the major points of my talk is to express my opinion that this is not the case. A solar cell is, of course, a much simpler system than a human body, but it's still complex enough to prevent complete predictability. And I would like to illustrate this with the example of the DISC cell. DISC was a European-funded project we have been lucky to conduct together with other WIO-owned partners from all over Europe some years ago. And in this project, we targeted the cell structure as shown here. It's a double-side contacted crystalline silicon solar cell with the best carrier selective junctions on both sides that were available at this time. And those are based on a thin interfacial oxide with either N or P-type doped silicon layers on top. And that's why we call them polysilicon oxide junctions. And we also managed to reduce the parasitic absorption Mathieu has introduced in his talk by applying very high transparent TCOs. We also reduced the resistive losses by applying low resistive metal grid and high mobility TCOs, and we even managed to substitute the indium-based TCO by zinc oxide and by substituting the silver metallization by copper-based plating. And therefore, It appears to be a very promising concept, but eventually we failed to achieve record efficiencies with this device. And this was because the reality often holds some stumbling blocks which can hardly be foreseen in advance. And in this case, the stumbling block of reality was the detrimental interplay of the TCO deposition with the passivation quality of these polysilicon oxide junctions, which turned out to be much more critical than in the case of an amorphous silicon heterojunction. And I think this is a good example that parallel evaluations of multiple approaches are necessary and justified. And when we now go beyond single junction concepts, the number of possible routes explodes. Even if we only focus on multi-junction concepts and disregard other concepts such as interband absorption, the number of options for the materials, for the absorbers of the different subcells, but also for the carrier selective junctions and passivation layers, the number of options for the configurations, for the subconfigurations of the tandem cells, for the interconnection scheme in the case of a monolithic tandem device, either tunneling or recombination junction, the number of module concepts, and the number of deposition methods. And for other techniques, it's really huge. So it's a really huge matrix, and I would like to illustrate you here with this nice table from Emily Warren without going into detail. I don't want to explain it in detail here, but I just want to show that even such a tiny little subsplit as the subconfiguration of 3-terminal cells contains a large number of variations. So we have a huge matrix, and we therefore need, of course, a parallel investigation of different routes. But since this matrix can impossibly be factorized completely, it's also necessary to do a pre-selection of the most promising routes. And for this pre-selection, I would like to acknowledge the current progress in the development of advanced characterization techniques, for example, the photoluminescence-based characterization techniques in the field of the perovskites, which allow for fundamental device physical insights already on very simple test structure level and allows for an acceleration of the development. But also you have to narrow down the most promising routes by combining research addressing cost aspects, material availability, environmental aspects, and stability issues. And one of the outcome of the nice paper from ANU was that the tandem cell could indeed become cost effective on LCOE level for residential applications under some assumptions on their additional costs and their degradation rate per year, but only if it achieves efficiencies of 28% or larger. And now let's come back again to one concrete route, the silicon-based photovoltaics. Here, Martin Hermle and team have published this nice prediction of the median efficiencies in production. And we are now here at this dashed line, and according to his prediction, and indeed according to the recent announcements from various companies, we are now at the beginning of the transition from the mainstream, from PERC-based mainstream to a passivating contact-based mainstream. The nice thing in this graph here is that it's so general that it allows for different interpretations so that almost everybody can agree with it. For example, for these passivating contacts, Meyer-Burger and others are following the amorphous silicon heterojunction-based approach, while companies such as Hanwha Q-Cells or Longi or Trina and others with a strong background in the PERC processing are following the high temperature route. If we now look on the right-hand side of this graph for the prediction of the tandem cells, and if we believe this 28% efficient threshold, and we think this projection of the slope of this curve with 0.5% efficiency increase per year holds, then it will take further 10 years till the mainstream is shifting to tandem technologies. However, in the past, there have always been some front runners, for example, SunPower or Panasonic or LG and others, and probably there will also be some frontrunners in the future. And as you all know, for example, Oxford PV is trying to become one in the field of tandem cells. It's also interesting to overlay to this graph of the median production efficiencies, the lab records from the annual efficiency chart. And as you can see, it follows roughly the same trend, but the curve seems to be shifted around 10 years ahead. I would like to acknowledge a couple of innovations in the field of passivating contacts, and Mathieu already introduced this field quite a lot, and it's interesting that we picked similar examples for recent innovations, in particular the one regarding the simplification of the process sequence for silicon heterojunction IPC cells. And I asked Meyer Burger Research and CSAM for their latest status during the preparation of this talk, and they kindly allowed me to present you this new, even unpublished result. It's a certified 24.7% efficient single cell laminate, as you can see here, made out of a 25.2% efficient silicon tunnel IPC solar cell without indium on the rear, and it's based on the smart wire technology. They asked me also to acknowledge this Swiss Confederation for funding. From the field of high temperature based passive winning contacts, I picked the example of this lab type cell from Fraunhofer ESA, published this year. And as you know, they have a boron diffused hole collecting junction on the front, and this conventional diffused junction implies higher recombination losses than a passive winning contact, and therefore it should be restricted to smaller area fractions. But in this case, you have to balance recombination losses with resistive losses, and obviously this balance worked out quite well on this 26% efficient lab type solar cell. At ISFH, we are following a quite distinct cell development roadmap, which is shown here and which combines our background in the PERC Plus technology and in the Polo technology. So we are starting from the PERC Plus solar cell as shown here, and for a short-term concept, we are substituting the phosphorus doped emitter with an electron collecting N-polo junction, while keeping the aluminum alloyed P+ regions for the hole collecting junctions. This can be done either in a rear side contacted version, this is the polo IBC cell, or in a double side contacted version. And this combination of these junction schemes has a very high combined selectivity and allows for rather high efficiency potentials. As calculated here, these numbers shown here are simulation results based on industrial feasible input parameters. And as you can see, the Polo IBC cell enables an efficiency benefit of 1.8% as compared to the PERC Plus benchmark, while the Polo back junction cell enables at least 1% efficiency benefit. And this short-term concept also has further application-related advantages, such as a lean PERC-like process flow, and therefore hopefully a low capex and low risk. And also the material consumption is quite low, in particular for silver. And for a long-term concept, we're working on monolithic tandem devices, either out of IBC cells, so it results in a 3-terminal device, or on 2-terminal devices. And we in particular want to use these Polo PERC-like bottom cells for this approach. And this was suggested at the last World Conference, and afterwards also considered cost-wise by our colleagues from Fraunhofer ESA, and they found that this is cost-wise a very attractive tandem concept. And in the next slide, I would like to show you briefly the status of these developments. And for our short-term concept, I picked the example of the Polo IBC cell. And we are working on full area M2 wafers, and we found that it's not only the development of the cell itself which is challenging, but also the measurement technique. So our measurement chart so far allows for the determination of the open circuit voltage, which is already quite promising, and of the short circuit current, but fill factor values are hard to reliably measured so far, and therefore I can only report you a pseudo efficiency out of the JCV curve so far of 24.7%, and which is increased to 25% with a double anti-reflection coating. On designated area, ISFH Caltech is capable to measure these cells, and the best efficiency so far is 22.7%. And again, we found here a stumbling block of reality, which prevents us so far from exploiting the full efficiency potential. And in this case, it's a spiking of the aluminum metallization here in the base finger regions, but outside the laser contact opening regions. But we think this is solvable. And for further ISFH talks on single junction concepts, I would like to refer you to my colleagues Ping-Su Min, Verena Merdens, and Michael Weniger tomorrow. Regarding our full tandem cells, I have to admit that we at ISFH are still working on our top cells. But nevertheless, we have been lucky to contribute a little bit to the field of tandem cells by cooperation with external partners. And in this context, I particular, I would like to acknowledge the excellent cooperation with NREL on 3 terminal cells and with KAT on the 4 terminal cells. But because my time is running out, and since these results are also published already, I would like to spend my last slide on a new result, and it's obtained together with Helmholtz Zentrum Berlin. And this is one of our first proof of principle devices on this perovskite polo PERC tandem cells. As you can see, it's a PERC-like bottom cell with a polysilicon interface. The efficiency of 21.3% at the moment is quite moderate still, but it's a good starting point. And some of the limitations are quite obvious. For example, the missing texture either on the front side or on the rear side or both. And in general, we found that this interface holds a lot of open questions, fundamental ones and process-related ones. So it also provides plenty of room for exciting research and innovations in the future. And with this, I would like to summarize my talk. My main intention of this talk was to express appreciation for the diversity in the approaches in our field, and also for a share of production sites, and also for the different concepts for different timescales. I tried to motivate this with similarities to the development of the vaccine for COVID-19. And in general, I would like to appreciate the impressive progress in each sub-area of PV, which is also summarized in this nice review paper. Regarding possible ISFH contributions to this field, I have showed you for the short-term concept, which might perhaps also help to relaunch European production, the polo back junction and polo IPC concept, and showed you the current status of 22.7% efficiency. And regarding long-term concepts, I have showed you the first proof principle device for a perovskite polo PERC cell with a 21.3% efficiency. With this, I would like to thank you for your kind intention. Enjoy the conference and watch out for the stumbling blocks of reality. So.
Thank you very, very, very much. Yeah, we certainly have to face reality every day in the lab, when you sometimes get the results you weren't expecting, but sometimes it can be the better results, which is good. Okay, so we have one question from the audience, and then one I will just ask myself. So I'll start with the one from the audience. How strongly does the number of possible routes narrow down if scarce materials are left out?
Well, I think this is a very complex question, because you can also reduce the material consumption for each cell concept, as Mathieu, for example, has shown with the localized TCOs on the heterojunction cell. So it doesn't have to be a road blocker, but it's at least an issue which has to be considered. I think it's a good guideline, and it will, for example, guide us in the direction of inorganic whole transport layers in the field of perovskites and so on. But it's hard to say that it will completely exclude different possibilities.
Okay, thank you very much. And then I just a quick question. At the beginning of the presentation, you showed a slide which indicated that it might be about 10 years before tandems would become mainstream. What is your personal perspective on that prediction? Do you think it might be sooner or later?
Well, I'm a researcher. I like to work on these concepts, and I like to be optimistic. But my experience in the past that it always takes a bit longer till the emerging technologies are applied in mass production make me a bit to be on the more pessimistic side. To be, I think 10 years is perhaps the lower guess.
Okay, great. Thanks very much. So I thank Robbie for his great talk and his being here this morning, and then I'll hand you over to Wim to introduce the final talk of this session. Wim, over to you.
Yes. Well, already indeed the third and final presentation in this session, and it will be given by Dr. Stefan De Luca, who is President and CEO at Energy Materials Corporation in Rochester, New York, in the United States. And please note that for him it's 3 o'clock in the morning. So really appreciate it that you're here live, Stefan. EMC, his company, is in high-speed roll-to-roll manufacturing of perovskite solar modules. And Dr. De Luca has a PhD in applied chemistry from the Colorado School of Mines. And among others, he was CEO at Daystar Technologies before his current position. He chose an intriguing and attractive title for his presentation, which is Electrification Without Limitation. And we really look forward to learning what that takes. So the floor is yours.
Thank you. So is this working now?
Yes, it is.
Great.
Thank you.
Super. So thank you. Thanks for the invitation to give this talk. And what I wanted to talk about is really looking forward to scaling up solar module manufacturing to meet the really aggressive goals that have been set out for renewable energy in the future. When we talk about electrification everywhere, I've got a collage of pictures here from the web. You can kind of pick your favorite section here, but everything from utility scale to building integrated photovoltaics, agricultural, transportation. There's lots of talk about green hydrogen and ammonia now. So all of these different applications are going to require photovoltaics as we move forward. When I give these talks to live audiences, I like to look out through the audience and ask this question and see how many people raise their hand. So the question is, will PV be 20% of global energy generation by 2050? Let's look in and see what that means. Okay. The first question, if you're going to get 20% of something, you got to figure out 20% of what. So you can go through and look at different assumptions about what the energy use is going to be in 2050. And I've copied a piece from a BP Energy Outlook that was just put out earlier this year. And what you see is the energy. If you go back to 2018 and then look at the differences in energy use going out to 2050, as they have different scenarios, and the net zero scenario looks like it's about 172,000 terawatt hours of energy generation. So slightly above what the energy use was in 2018. That slight increase, if you look at 20% of that, is about 34,400 terawatt hours. And one thing I want to look at is if we need that many, if we need 34,400 terawatt hours, how much PV do we have to install to get to that? So how much PV has to be installed in 2050 to generate 34,400 terawatt hours? Well, it depends, obviously, on where you put all of that PV. So in this curve here, what I've shown is if the average, this is on the x-axis, I've shown the average insolation. So if all of the PV gets installed, basically the average is up here at 7. So it's all out in the desert. We need a little over 13 terawatts installed. If we do a lot more work with PV installed everywhere, and if it's in all these different applications like BIPV, like vehicle integrated, you're not going to get those kinds of insulations. So you're going to move to the left on that curve. You're going to go up here and you're going to be up in maybe the 17 up to 20 terawatts installed to reach that 20% of energy generation. And then it gets even worse because, or it needs even more, I should say. This is the curve on the last one. If you look at the amount of installed PV, we typically talk about nameplate efficiency. So when you buy a solar panel, it's priced based on the nameplate efficiency. But when you look at the specs of a panel, and I pulled these out of a commercial sheet from one of the tier 1 suppliers, I have a 640 watt panel. When I put it under normal module operating conditions, that's really a 480 watt panel. So I've lost about 25% of the nameplate power here. So what that means is if I look at the normal operating, the module operating conditions, I have to take this blue line and move it up to the red line to get to the same 20% of energy generation. Okay, so it's really important to understand what we're actually going to need to install if we're going to meet that goal of 20%. Okay, I am going to talk about perovskites here. One of the really interesting parts of perovskite is that the temperature coefficient appears to be much better than silicon, and so even though you still have this difference between nameplate and normal operating conditions, it's a bit less of a difference. So I drew this curve in based on some papers. Of course, perovskite hasn't been scaled up. We don't know what this is actually going to look like in the real world with real modules, but just to give you an idea that focusing on the nameplate efficiency is not enough to really understand how much, how many terawatts of PV panels we're going to have to install. Okay, next step is I want to look at how do we get there? What do the growth scenarios look like? And one of the simplest ways to think about growth is just to put a constant growth rate on. So if you look at a 8.75% growth rate from going back starting in 2019 through 2050 to get to, and I'm targeting 17 terawatts here. So I picked that number out of the previous slides. If I want to get to 17 terawatts installed by 2050, and if I use a constant growth rate, what happens is the major parts of the growth all happen in the out years. And you see by the, in the late 2040s, where we are installing more than a terawatt per year in of PV. That's a gigantic growth. There's a better way to do this, and that is to accelerate the growth in the near term. So if you look at this, if you look at the red line here, this shows an accelerated growth. And what this lets you do is increase the capacity additions. That's the red line are the capacity additions early on. And then you can decrease that slowly over time. And what happens is your capacity additions increase, and you'll see if you integrate under this curve, what you'll find out is that you have this green curve, and by 2050 you end up at the 17 terawatts installed. So if you follow this accelerated growth, you'll follow the green curve. If you follow the constant growth, it's this sort of purple curve. The other advantage of the accelerated growth, of course, is that you get the benefit of all this added energy generation earlier on, and that really helps the process. Just a couple of other numbers. This 800 gigawatts per year is roughly, let's say if I have a 20% efficient average module efficiency, that's about 4 billion square meters per year of solar panels. And if you're selling this at 20 cents a watt, that's about $160 billion a year industry. Okay. If we want to scale up silicon, I'm not talking about material science here, but I want to talk about economics. This chart came out of NREL. They publish it every so often. They look at the economics of the silicon industry over here, and you can see that there's a lot of, in many years, the silicon industry is losing money, and when it makes money, it doesn't make very much money. So it doesn't look like a really attractive business to be in. There's a couple of issues about scaling. There's a high CapEx cost to build extra capacity. So you're really relying on continued government subsidies to expand, and you have poor economics that are shown here. And that really, up to now at least, has limited investments in building factories, except for in China and Chinese-controlled companies in other locations. That has created this geographically focused, which again is not ideal for large-scale deployment around the world. We end up with a highly fragmented value chain, and I'll talk about that in some pictures here. But one of the problems with the silicon value chain is we get these big imbalances along the value chain. So you get an excess, a new silicon plant comes up, you have an excess of silicon, it drops the price of silicon, everybody buys up. Now there's not enough capacity downstream, so they start building and it goes back and forth. It's like getting in a traffic jam where you have an accordion effect here. And finally, a lot of these emerging markets, you want lightweight and other kinds of flexible and different form factors besides rectangles. And it's a little bit harder to do that with rigid silicon than some other materials that we might look at. Okay, I talked about the supply chain here. I think everybody's probably pretty familiar with this, but again, if you think about when you're scaling up to very large volumes, you have to build 5 different factories, and these factories all have different capacities, so it makes the process difficult to have a really good control over the scale up. Right. Moving on to perovskite technologies, we have, what I'm going to do is go through a list of what is possible with perovskites. First is low capital cost to build factories. And what that does is allows us to get, once we get to scale, that we don't need subsidies anymore. We can get the manufacturing cost well below 20 cents a watt, and so that we can sell below that price, below 20 cents per watt, and we won't need long-term support to do that. There is a simplified manufacturing process that allows geographic diversity that relieves some of the political pressures about not having local manufacturing for local supply. And importantly, you also simplify the value chain. What that means is you can have a very high number of inventory turns. If you make your product in one factory with high throughput, that means you can flex your output with the demand as the demand fluctuates. Okay, and finally, in these emerging applications, we have flexible and lightweight form factors, ultimately high efficiency tandems, meaning perovskite tandems that can also address some of these new applications. Right? How are we going to do that? When I talk about high-speed roll-to-roll manufacturing, and what I've got here is a concept where what's really important here is that we are coating all of the layers for the device. We're essentially making a full module minus the junction box on the end with a single tool. Right? So we're coating all the layers, including the transparent conductors. In this case, we're putting transparent conductors on both sides to make a bifacial module. All of that's happening at the same speed in the same tool. And that's what gives us the financial and capacity advantages here. All right, so if we look at high speed, again, we're talking about high speed roll-to-roll manufacturing. I've shown a couple of little charts over here to show the impact of the speed. This first chart shows the cost breakdown if you're at something like 3 meters a minute, where the major part of the cost of manufacturing a perovskite device then is labor and the equipment tool. So if you're doing roll-to-roll manufacturing, you don't want to run at low speed because you're really the tooling and the labor that it takes to run those tools is going to be a large part of your cost. Once you increase your speed here up to 30 meters a minute, what happens is your cost is almost all material. The labor and line cost goes down to a couple of percent and so on. So that's really the advantage of roll-to-roll manufacturing, is when you can do the entire process at high speed, it reduces the cost completely to the BOM. Just some metrics here. Again, this is looking forward, but at 20% efficiency, at 85% uptime and 92% yield with 30 meters per minute, this one tool, and this is our model manufacturing tool here, it's an 8-station coater, would produce 4 gigawatts per year. Okay, so the capex for that facility would be around $100 million or $25 million per gigawatt. Compare that to more than 10 times that amount for the silicon supply chain. And if you do the arithmetic when you get to scale here, you have a feasibility of getting below 10 cents a watt manufacturing costs there. So the economics really drive this idea. So again, if you go back to this this accelerated growth curve that I showed before, and just take that and say, what does that look like in terms of CapEx? And if you look at just doing this with silicon model, here's what the CapEx would look like to go through that. With perovskites involved, what you can see here, and again, we don't have perovskite in manufacturing today, so it's going to take a while before it comes online. But if we can start up in 2025, building up the capacity, we can start to decrease the silicon capacity additions. That doesn't mean we're getting rid of silicon. It just means we're not adding more capacity on silicon. What you see is this very small increase in manufacturing CapEx to give us the same output as we would get with this CapEx. Okay. So again, the summary of this: perovskite PV is adaptable. We can make low cost, lightweight. We can make tandems. We can meet all of these markets. But what does that look like? What I want to do is show you kind of where we are in process. Again, this is a target manufacturing tool. This is what that manufacturing tool would look like. The way this works is this is actually the coating tool here, and this is sitting underneath the coating tool. These are the ink delivery systems. So you have these systems where you mix up the ink in one and you deliver it from the other. So you have continuous processing going on. We are using multiple substrates, including polymer substrates and glass substrates. One of the advantages of using a glass substrate is you have you're coating on a barrier layer, and you can do nip lamination where you don't have to go through a vacuum lamination step to get to your module. That decreases the CapEx and increases the throughput. I want to show you a couple of quick videos. This first one is you're going to see a pilot scale up coating on a gravure coating of perovskite. So let me see if I can get this thing to start. There we go. And so what you see here, I'm going to let this guy put that little patch on so you can see that it's actually moving. But what we're doing is we're coating the perovskite down here, and you can see the film is still wet, so you don't see anything here. But when you come up here, you see a kind of a sharp dividing line here. That's where the perovskite is forming. And then you see this nice perovskite film on top here. Okay. So this is the scale up process. Again, scale up and roll to roll is all about speed. It's not about the width. It's really about the speed. And that's what you have to develop during the scale up process. You have to develop new ink formulations that allow you to go from wet laydown to uniform perovskite material. And again, you have to print all of the layers. So in this case, what I'm going to show is a couple of videos of printing.
Time is over, but so if you can do this quickly.
Okay, that's 30 meters a minute on glass. Okay. So I want to acknowledge the partners that we're working with. We work with this group of people in our scale up and in our development efforts. Thank you. Yes,
thank you very much for this exciting outlook on perovskite PV. Time is over, as I mentioned, but Robert, can we afford to have 2 questions?
Yeah, I think we're okay because the next session is starting at 9:45, so I think we can spare a minute or 2. Yeah.
Okay, so a few questions came in, and I would like to, well, first of all, perhaps start with the assumption that you made of PV providing 20% of total energy, and one of the people in the audience asked whether this is sufficiently ambitious or enough.
I don't think so. And one of the one of the things I like to do when I ask a live audience that is look out, and typically what I see is, everybody in the audience raises their hands except for the people who are saying, no, 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 it's going to be more than that.
Yeah.
But the point is, it needs to be at least that. If you look at what other people are forecasting, if you look at IRENA and IEA, sorry, and so on, you will see 20% is kind of the maximum that those organizations are proposing.
Okay, then the final question. In your forecast of how much you need to produce per year, did you take into account the fact that you have to replace modules because MEF has an end?
In that case, no, I have not added that. Right now, there's less than a terawatt of modules, sitting out in the world.
Yeah.
So some of those will have to be replaced. But again, it's within kind of the error bars of what we're talking about here. Is where do we put these things? Are we going to need 17 terawatts or 20 terawatts? I think it's going to be more like 20.
Okay. Okay. Well, thank you again, then,
Okay.
Mr. De Luca, and I give the word to Robert again to close this session.
All right, great. Thanks very much. I'd like to thank our three speakers as well, and of course for all of you for being here. It's obviously not the same as being in a large plenary room and you can see the large audience, but I can confirm we do have a large audience here this morning. So we've been sharing this together with a large number of delegates, numbering in the few hundreds, which has been very, very encouraging. As before I close the session formally, I'd like you just to remind you that very shortly at 9:45 we'll be starting the ceremony for the Becquerel Prize Award. So I would just say, please do go and take a short break, like a 10-minute or so break. Grab a beverage of your choice. If you're working through the night, you might want to take a glass of milk, a cup of coffee, whatever. I'll leave it up to you. But please do come back in about 10 minutes time to watch the very exciting Becquerel Prize ceremony. And the last thing I'd like to remind you as well, as I said before this session, was please get the maximum out of the networking capabilities that we have on the tool. You can easily find and message other delegates, but to help this process, make sure you go to your user area and indicate your own topic areas of interest, the tags, so people can find you more easily. And also you can add a short biography so people understand a little bit more about your background, and also upload a photograph so you can be more easily recognizable. So please do try and do that. It'll help greatly in the networking through the week. So with that, I'd like to thank everybody again for their presentations. Thank my co-chair, Wim Sinke, and we close the session, and I look forward to seeing you again in 10 minutes time for the Becquerel Prize. Thank you very much.
Hello, good morning again, and welcome back to this morning session. I hope you could enjoy the first plenary and also enjoy a coffee. Of course, in this case, we all have to bring our own coffee. So we will proceed now to the Becquerel Prize ceremony that will be led by Christophe Palif on behalf of the Becquerel Committee. Christophe, please, I hand over to you.
Yes. Good morning, dear friends of our solar energy community, dear representative of the authorities, dear conference organizer. It is a pleasure to preside over this official Becquerel Prize ceremony. Last year, we celebrated the 200 years of the birth of Edmond Becquerel, who discovered the photovoltaic effect. I really wish that he would be here today to see the tremendous progresses achieved over the last decades. Just amazing. In 1989, the European Commission, on the occasion of the 150th birthday of the discovery, introduced the prize for outstanding merit in photovoltaic. And there are many people who dedicate themselves fully to the field of solar energy and photovoltaics, and we would need many more prizes. So I want to address here special thanks to all those in particular we prepared nomination forms who supported candidates. And on behalf of the Becquerel Committee, I would like to announce officially our 2021 laureate. There is not so much suspense here because likely you already read it. Our 2021 laureate is Ulrike Jan. So thank you, Ulrike, for your outstanding and continuous contribution to the field, which is extremely important and sometimes underestimated in its difficulty of the quality, performance, and assessment of photovoltaic modules and systems. We're going to learn more about that in the coming speeches. And as you know, the tradition is that there is a laudator, someone who will speak about Ulrike and her work. And today's laudator will be Thomas Nordmann. Thomas is a Swiss pioneer of solar energy, whom I'm sure most of the attendants know. So Thomas, the floor is now yours.
So, dear Ulrike, Jan, dear Christophe Palif, ladies and gentlemen, it is a great honor for me to be invited to make a few remarks on Ulrike's professional curriculum vitae. I first met Ulrike in Bonn, 1992. The setting, the Federal State Support Group of the Germans' 1,000 Roofs program 30 years ago as a Swiss observer. Ulrike Jan represented the state of Lower Saxony as the only woman in this otherwise all-male panel. Ulrike had already used her expertise as a physicist to explore the particularities of photovoltaic, which was still in its infancy. At the time, our award winner worked as a project manager at the ESFH Institute for Solar Energy Research in Hameln, Germany. Ulrike presented her first system paper as a co-author at the 11th EU PVSEC conference in Montreux, Switzerland, 1992, under the topic, the German 1,000 Roof Photovoltaic Program, System Design and Energy Balance. Already at that time, she was dealing with the issue of system performance. The author's approach went beyond the question of the efficiency of cells or modules. Factors influencing the correlation between the reference yield and the final yield were investigated using the insights of physics. In her later career, I would like to emphasize her great commitment to the activities of the EU PVSEC Task 2 and Task 13. Ms. Jan has been the operating agent of Task 2 and later Task 13 under the title Performance, Operation and Reliability of Photovoltaic Systems since 1997. She has shaped the work of the task for 25 years and led it to great success. From my personal point of view, as a long-time member of Task 2 and Task 13, what can I say about Ulrike Jan's performance? My first observation is under the title Swimming with Style Against the Tide. Our community is used to swimming against the tide. In the past, we were seen as a stubborn innovators group trying to promote and develop a technology that was far too expensive. Ulrike was always at the forefront. When I look at the list of the Becquerel Prize laureates, she's the second woman laureate after Michael Terodde. She received the award 2008 as a member of the European Parliament. Ulrike Jan is the first female scientist to receive this prestigious European prize. This means she has swum against the tide for photovoltaic professionally in two ways, both as a scientist and as a woman. Extraordinary and successful life achievement. So, what is my second observation? My second observation is under the title Lifelong Project Support. Ulrike was always managed to take her most important project with her, the responsibility for the management and the coordination of Task 2 and 13, even when she changed jobs. This means her employers, ESFH to ZAE Bayern, later TÜV Rheinland, and today YDI Renewable, have accepted to leave the dossier with her in recognition of her expertise. My third observation is remarkable leadership style. My observation, the Task 13 team has now more than 80 members representing 27 countries. I can confirm that Ulrike does not play the boss in the working group, but acts as a coordinator, the motivator, and the coach. A large part of her work is between the biannual meetings. She analyzes and supports each activity individually. She is also often the visible or invisible co-author of the important reports of Task 13. This collaborative leadership style has led Task 13 to full flowering. Be aware that the task has submitted a total of 10 valuable PVPS publication reports in the past 2 years. I'm pleased to have been able to meet with Ulrike Jan again and again during the past 30 years in course of her efforts for Task 2 and 13, EU PVSEC Program Committee, PV Staffelstein, and more. With her wise, diplomatic, and motivating leadership style, Ulrike has made an important contribution to ensure the quality of PV system. This at a time of massive cost reduction combined with exponential expansion of the market volume. This is one of the great challenges of our industry. The market expects us to provide products, systems, solutions with a life expectancy of 30 years and more. The Task 13 team under the leadership of Ulrike Jan has been making an important contribution to this challenge for the last 25 years. Ladies and gentlemen, Ulrike Jahn has made an outstanding contribution to the development of photovoltaics. On behalf of the entire PV community, and also in the name of the present and the former PVPS task members, I congratulate Ulrike for this well-deserved award. Thank you.
Thank you very much, Thomas, for succeeding in this very challenging exercise and really highlighting some of the key aspects of Ulrike's contribution. Now we're coming to the time of the official prize awarding, and I have the pleasure to welcome Christian Thiel, who is representing the European Commission. Mr. Thiel works at the European Commission Joint Research Center, where he's head of unit for energy efficiency and renewable, and it is a pleasure to have him on stage and to appreciate also the collaboration with the European Commission for the Becquerel Prize.
Thank you very much, Christoph. Good morning also from my side. I've here in front of me the diploma of the European Becquerel Prize for Outstanding Merits in Photovoltaics. And I will soon hand it over to the winner. But before doing that, I will read to you what is written on it. To mark the 150th anniversary of Alexandre Edmond Becquerel's discovery of the photovoltaic effect in 1839, the European Commission founded in 1989 the European Becquerel Prize for Outstanding Contributions to the Development of Photovoltaic Solar Energy. It is awarded for the 29th time in 2021 on the occasion of the 38th European Photovoltaic Solar Energy Conference. After a public nomination phase, the prize winner was selected by the Becquerel Prize Committee. Ulrike Jahn is the 29th Becquerel Prize winner. She receives the award in honor of her contributions to the field of quality performance and assessment of photovoltaic modules and systems. Ulrike Jahn has worked all her career for the development of PV technology with a focus on reliability and performance that new electricity generation technologies must demonstrate to be accepted in the market. Her activities have evolved from working for the 1000 roof PV program in the 90s to module reliability characterization and PV system performance assessment, up to the definition and establishment of methodologies for good practice to reduce the technical risks during the implementation and operating life of PV systems. Through her various activities, including within the IEA PVPS program, she became not only one of the world-leading experts, collaborating with 80 experts all around the world, but also one of the faces in the field and thereby a role model for young scientists and engineers. This is what is written on the diploma. Let me now add a few personal words of appreciation. Dear Ulrike, I want to warmly congratulate you on this well-deserved recognition of your work so far. From the Commission and also the Prize Committee, we are delighted to honor your enormous contribution to improving the quality and reliability of PV systems. With your leadership in international efforts to share best practices for the benefit of the community, you made a real difference for PV deployment, and we can see it every day outside on the rooftops and on the fields in Europe and worldwide. Europe and the world is counting heavily on PV to help achieve the energy transition. Reliable and sustainable technology is essential for the major investments needed for this. Dear Ulrike, please continue with your important work in PV and keep inspiring others to follow your path. And now I would like to invite the others back on stage so that I can hand over the diploma to Ulrike. Ulrike, here it is. Are you ready to receive the award? Yes, she is.
Oh, wonderful. Ulrike, if you allow me, I also have something for you. I'm also extremely glad to share this moment and these few organic roses with you. Please take them. Can you get them? Ah, okay, here they are. Congratulations, Ulrike. Congratulations.
Thank you.
Hello, Christoph. I also have flowers for Ulrike. Can you hand it over to her?
Yes, please.
Okay.
Ah, okay, here they come. Thank you very much, Thomas. Ulrike, even more flowers from Thomas, please. Take them. Fantastic, fantastic. Wow. So Ulrike, with all this Laudatio and flowers, I think you are in an extremely good spirit to continue for the last part of the session, which is the chance to listen to the awardee presentation. So we are now all ready to listen to you. Please, Ulrike.
Thank you very much, Christoph, dear ladies and gentlemen, dear colleagues, dear Christian Thiel. First of all, I would like to thank the Becquerel Committee for awarding me this special prize. In particular, to thank my long-term companion, Thomas Nordmann, for his flattering laudatio remarks. Thank you, Thomas. I'm overwhelmed by the recognition I have received, and I'm still not convinced that I deserve all these honors. I understand this award as recognition for all the people in our PVPS network and PV community, and especially for the Task 13 experts who have contributed to this work and deserve the award as well. Solar is a new king of electricity markets was one of the first key messages from IEA Executive Director Fatih Birol at the launch of the IEA World Energy Outlook 2020, in which he noted that solar PV power is becoming the cheapest source of electricity in many countries in the world and will therefore continue to grow strongly in the coming decades. The IEA PVPS Power Systems Program is one of the technology cooperation programs within the International Energy Agency. It was established in 1993 to promote international cooperation that supports the role of photovoltaic power energy as a cornerstone for the transition to sustainable energy systems. In 1997, I became involved in the PVPS network and was immediately convinced that the concept at looking at PV from the component to the system level to market application and conducting joint research projects on a global scale to strive for the future sustainable energy system was the right approach. Cell and module efficiencies and performance improvements are continuously driven by significant technological advances in wafer technologies, new cells and interconnection technologies, and new module designs. In the wake of this rapid technology development, Task 2 of the PVPS program started in 1993 and addressed quality issues and processes for small PV systems when 15 megawatt PV per year were installed worldwide at sales prices of over 10,000 euro per kilowatt peak for small rooftop systems. The growth of worldwide installed PV capacity was dominated by Japan and Italy, Germany, and the US in 1993. Task 13 then focused on the reliability of PV modules and systems and started in 2010 until today, when 139 gigawatt per year of PV power plants with investment costs below 1,000 euro per kilowatt peak are installed worldwide. During our joint work from 1993 to today, the installed capacity has increased by 4 orders of magnitudes per year, while the investment costs have been reduced by more than a factor of 10. This means a price slope of 25% per year over the last 30 days. Last 30 years. The cost of electricity, the LCOE, is affected by the cost of capital, the operational expenses, OPEX, and the degradation rates over 20 or 30 years of operation. If we want to reduce the risk of our PV investments, We can increase the O&M measures, but higher OPEX costs will affect the LCOE. This publication by PVPS experts calculates and quantifies the impact of certain quality measures on the LCOE. We need to understand what are the drivers for increasing cost and reliability increase in a cost-effective way. We started small in terms of experts in size of installed PV capacity, 5 kilowatt on rooftops up to 500 kV for ground-mounted systems. But we were determined to achieve our goals and results. 10 experts from 6 countries in Europe and Japan working on PV system issues in different countries and climate zones. We developed the first PV database containing measured yields and performance ratios of PV systems distributed around the world, which can be freely used by the stakeholders in the PV community. In 2010, we started a new approach to studying the performance and reliability of PV modules and systems. In this context, a detailed PV module failure handbook was developed, discussed, and published. We continue to investigate the long-term performance of systems, technical assumptions in PV modules, and the assessment of PV failures in the field. The current phase, we have produced more than 10 technical reports. The published reports can be downloaded from the website given below, and the key findings will be presented by the main authors of the different topics during this conference. I will highlight the results of 2 reports only, while the technical details will be given in the plenary lecture on Wednesday. The drastic drop of module prices had led to the development and implementation of new PV module designs that either increase the module performance and/or lifetime or reduce the production costs. Many of these innovations involve the use of new and novel materials. As a result, modules are often produced and sold without knowing the long-term performance and reliability of these new materials. And this represents a technological risk for the PV industry. The process of materials innovation is further complicated by the complex interactions of the components within one module. The advantages of one material can be nullified by its interaction with another component. The external and internal stress factors affect the performance and the long-term reliability of PV modules. Compatibility testing of PV module components will become increasingly important in the future as a variety of materials and components will increase. In addition, new modes of degradation may occur. Matching components and materials can reduce degradation rates and avoid certain types of degradation. Single stress testing often does not detect certain types of degradation observed in the field. Therefore, combined or sequential stress testing is recommended and required. There is a constant need to adapt test methods and test standards. Gernot Oreski will present the detailed results and challenges for new materials and developments, as well as the role of polymers in PV in 2 conference presentations. Best practice guidelines for improving PV plant operation are often applied only as long as the recommended measures will bring benefits to the implementers, the EPCs and O&M companies, and to investors whose main interest is to lower the risk and maximum profit from an economic point of view. This leads to the key challenge: how to prove the effectiveness of measures and to justify their application. After all, the technical best solution is not always the economical best solution. In a first step, we wanted to investigate this. How can one quantify the fundamental impact of a technical risk? We invested and applied 4 different methods to assess technical risks, including the failure mode and effect analysis and the cost priority number method. Their application depends on the maturity level and the data availability. Choosing the best method for individual risk analysis is a key question. In the second step, we investigated the most important risks by collecting real case studies and creating a technical risk database with the information obtained. We created a collection of PV failure data sheets for all components and for different project phases. PV failures are assessed according to 5 different performance categories and 3 safety categories that had been previously defined. We continued to collect statistical risk data, which requires detailed measured failure input data that allows us to generate statistical data on PV system degradation rates and power losses based on failure types in different climate zones. The chart in the middle shows the failure frequency of PV module defects affecting the system performance with slow degradation over time and sudden events. In the third step, we used 3 real case studies to calculate the economic impact of soiling and PID as an example over the project lifetime of a PV plant using the revised CPN method. This method not only allows us to estimate the economic impact of certain failures on the LCOE, but also to evaluate the effectiveness of the mitigation measures. Their calculations have shown that it is possible to determine the best economic solution for a given PV system, a given failure scenario, and a given mitigation approach. An example, cleaning routines and frequency in case of PV power plant soiling. The CPN method applied shows that in practice, it is important to understand how risk mitigation measures can be considered as a whole in order to calculate their impact and thus evaluate their effectiveness. To conclude, solar bankability must be data-driven. Big data is available, but it needs to be better organized and digitized, relying on interconnected digital platforms. Digitalization is a driving force that can be used ultimately to ensure a cost-effective increase in the quality and reliability of PV components, systems, and projects. Data-driven evaluation of techno-economic performance indicators is a key to taking total cost of ownership decisions support to the next level. The European Technology Innovation Platform for PV, ETIP PV, has developed a strategic research and innovation agenda for photovoltaic science, technology, and engineering in Europe. The agenda analyzes 5 interrelated PV research and innovation challenges. The second challenge is to improve the lifetime reliability and sustainability of PV systems through advanced technology and manufacturing and applications. Further insights will be provided by ETIP PV Chair Marko Topic in his plenary presentation on Wednesday. Thanks are due to the German Federal Ministry of Economic Affairs and Energy for its continuous support on numerous projects. Thanks are also due to the European Commission for its support, especially for projects under the Horizon 2020 program. I would like to thank my current and former employers for their support in carrying out research projects and client projects in the field of PV quality. I'm deeply indebted to all colleagues who have shared their experience with me and worked together to achieve our goals. My sincere thanks also go to the ETIP PV committee, whose members are excellent source of scientific and technical expertise and competence. My special thanks go to the great PVPS network, all the task experts and the chair and their secretary, Mary, the executive committee members I have the pleasure to work and sometimes travel with, who not only share the spirit and passion for the quest for a future global sustainable energy system, but also have many stimulating conversations beyond working level. And last but not least, I would like to thank my family, especially our sons, Ricardo and Marcelo, for their patience and support. Some thoughts to share. It is a unique time for photovoltaics. For 100 years, we have been burning fossils to produce energy, and now we are witnessing the dramatic effect of CO2 emissions around the world. I believe that climate change must be taken seriously. There is no time left to act if we want to meet the Paris climate targets and care about the living conditions of our children and grandchildren. To meet 100% of our electricity needs with renewable energy, we need to invest massively in solar and wind power. Solar PV is the most important driver for the sustainable energy transition. My wishes for the industry are: PV manufacturing capacity must be increased significantly to reach the terawatt era. I believe it is important to take advantage of the recent rapid cost reductions in building PV manufacturing capacity, combined with a strong increase in demand for the various forms of PV, to develop made in Europe production capacity. For a large deployment of photovoltaic, we need to work together to ensure that the sector becomes fully circular while retaining PV's proven strengths in terms of cost, performance, and reliability. PV technology is capable of integrating other sustainable methods into its use, such as dual use of land for agricultural PV or building PV. Finally, solar energy is unique in that it can provide energy for all people around the world. Professor Götzberger stated already 25 years ago, solar energy is not just a topic for idealists, but concerns everyone on this globe. The number of people without access to electricity has fallen from almost 1 billion in 2014 to 770 million in 2019. This figure is still unacceptable high. Solar PV has the potential to provide rural and urban households with a minimum level of electricity to raise their standard of living and to provide access to health facilities, education, and small business. For some countries, significantly improving access to electricity will remain a global challenge in the coming decades. I strongly believe that PV electricity will play an important role in addressing this urgent challenge. Thank you very much.
Thank you, Ulrike, for this excellent presentation, overview, and inspiring thoughts. And I think it illustrating well the complexity of the topics on which you worked. And also you succeeded in introducing some of the next contributors to the conference. And I also think as a device person that it also illustrates a huge long work that goes from making a lab devices to a module that produce energy in a reliable way in the field. With that, we're coming to the conclusion of our Becquerel ceremony. I would like to thank all participants here, also the people who worked in the backstage. We had to do rehearsal. We had a lot of support from Vip, from Nigel, from Robert. So thanks to all of you. And I look forward to receive nomination for 2022 Becquerel Prize. And in the meantime, I wish you all a fantastic conference and stay tuned. In 15 minutes or 13 minutes, the opening address will start. Have a good day. Bye-bye.
We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to
Welcome back, ladies and gentlemen. Please let me welcome also all that have joined us now. And don't forget that you can still watch the great plenary talks we had this morning, and also the Becquerel Prize winner keynote. So it has been an exciting morning. We will continue now with the opening addresses. And our first speaker in this welcome address is Kadri Simpson, the European Commissioner for Energy. She is also a member of the Estonian Parliament and chairman of the Estonian Centre Party. She was previously Minister of Economic Affairs and Infrastructure. Ms. Simpson, the floor is yours.
Where is unmute? Good morning, ladies and gentlemen. I hope that you can hear me, and it is a pleasure to speak with you today, and a great way to start the week. I want to begin with congratulations to Ms. Ulrike Jahn for winning the prize, and your pioneering work has been acknowledged, and we look to you as a great example of the great minds that we have in Europe working in the solar PV space. This is clear that we want to harness that potential, and so if there is one message to be passed from me to you today, it's that you have the green light. We in the Commission, we are ready to speed up, scale up, and invest in solar PV. On the road to net zero 2050, your industry will play a key role in driving us there. So today I want to speak about 3 important points on that road: the signals, the roadblocks, and the crossroads of opportunity. First, let's talk about positive policy signals. As I said, you have the green light from the Commission, the Green Deal green light, you could call it, because since December 2019, as you know, the central political priority of this Commission has been reaching climate neutrality by 2050. Since then, with every ambitious strategy we have launched in the energy portfolio, we are sending you a clear signal that solar PV is a major block of that ambition, and I see it as a literal golden thread running through each of the strategies. Our energy system integration strategy aims to shape a system that is largely renewables based, that includes a strong solar component. Our hydrogen strategy holds renewable hydrogen as a priority, and that will only be possible with mainly solar and wind energy in its production. For our innovation wave, decarbonizing our buildings is a must. So integrating renewables on site like solar rooftop panels is a tenet of the strategy. And of course, when it comes to offshore renewable energy strategy, it goes without saying that there is huge potential for emerging technologies in floating offshore solar, which is promising, moving from pilot to demonstration phase in coastal and near shore areas. The road to 2050 also has one very significant pit stop on the way, 2030, because success by mid-century will only see the light of day if we can reduce emissions by 55% already in the next 10 years. In July, we launched the largest legislative and policy package to date to help us to do just that. And it was imperative to revise our renewable energy directive and bring it in line with our newer, more ambitious targets. The energy efficiency directive is also a key instrument in driving innovation in your sector. When it comes to solar deployment, it will more than double by 2030 compared with today. Up to 320 gigawatts, the increases in production capacity this calls for is enormous. And we are talking about additional capacity of around 18 gigawatts per year between now and 2030. And then as high as 34 gigawatts per year between 2030 and 2050. And these projections are also pointed to in the updated industrial strategy that we adopted in May. We called for a more strategic approach to renewable industries. This is fully in line with the European Solar Initiative, also launched in May, and aims at a trusted ecosystems of players, industry, research, investors, universities, and regulators. And we want to support the opportunities and seize the conditions to rebuild a European strategic industry in PV. All told, these positive signals should give the green light to strengthen our PV industry, to grow it, and to benefit from the huge job creation potential we are already seeing. The second point I want to make today is about clearing roadblocks. Yes, your industry has the green light, but this is only beneficial if you have a clear path ahead with no obstacles. And unfortunately, as you know, as we scale up solar PV, we are seeing a new generation of both practical and legal roadblocks coming up. Administrative issues and insufficient spatial planning can lead to draw out and expensive permitting procedures across many member states. I know this is a particular problem for ground-mounted PV projects and solar thermal installations. And looking at how member states grant permits is only one side of the coin. We also need to boost investments, power purchase agreements, and cross-border cooperation. Grid connections are also a potential pitfall. I recognize all of these issues as standing in the way of success for solar, and we are tackling it head-on. The current Renewable Energy Directive introduced new requirements on permitting, while the revised directive encourages member states to go even further in coordination and in the allocation of resources to the right authorities. In the next few months, we are focusing on the full implementation of the existing provisions. This way, we can help project promoters tackle the issues they are facing on the ground. And we also think a benchmark of good practices needs to be proposed for the delays in permits being granted. Not only will we address this in the State of the Energy Union report, we plan to issue a full set of guidance of good practices next year. Third and finally, on this path to 2050, I want to mention the crossroads of opportunity. That's where we find ourselves at now. Scaling up our PV capacity is a necessity for the climate. It's also an important part of rebuilding our economy post-COVID. There is a massive growth opportunity on our hands, an opportunity that needs to be seized. In the EU, we have brilliant minds. We have world-class research institutions, a highly skilled labor force, and solid existing industry players that will form a basis for a strong future European supply chain. We are leaders in solar technology R&D and looking for new applications in buildings with building integrated photovoltaic, in transportation with vehicle integrated photovoltaic, and in agriculture with agro-PV. Ulrike Jahn's achievements are a prime example of that. And we also host some of the most advanced companies along the solar value chain. Even so, the EU position has dramatically fallen behind in PV cells and modules manufacturing in the past number of years. As of today, every single one of the top 10 manufacturers of PV cells and modules are mostly manufactured in Asia. That's why I say we are at a crossroads of opportunity. We need to make sure we choose the right path, build on our potential, and avoid falling behind like we have. We do that by building on our strengths. Asia may be leading the way in cells and modules, but we are competitive downstream in the value chain, especially in monitoring, control, and balance of system segments. And we have some of the world's leaders in inverters and solar trackers. EU companies have a strong foothold in the deployment segment, many of which are present and listening today, some of which are continuing to gain market share worldwide. And I'm also proud to see that equipment manufacturing has a strong place in Europe. Taken together, we can see that we are fighting for a leading position in solar PV. There is great potential to take our industry even further from the public policy and investment perspective. We are working on having the right formula of conditions in place so that you are confident in growing your businesses to the next level. So as we find ourselves at this crossroads, I'm saying seize this opportunity, play to your strength. Ladies and gentlemen, these are my thoughts on the road ahead for solar PV in the next 3 decades. Both food for thought and a call to action. We are ready to bring more structure to the industry and support the role solar energy can play in achieving our climate objectives for 2030 and 2050. And today's discussions are an important part of that. And I hope they continue in October when we aim to have an event on solar PV in the context of the Clean Energy Industrial Forum, relaunched last year as part of our offshore strategy. This is another chance for a meeting of minds and to facilitate the much needed discussions. Until then, I wish you an excellent rest of the conference today, and I hopefully will witness a very fruitful discussions. Thank you.
Thank you, Ms. Simpson, for this broad vision of the future of PV in Europe that we all look forward to work on it and develop. I want also to say a few words about the conference. I'm João Serra, the professor at the University of Lisbon and the general chairman of this edition of the European PVSEC. So let me start by welcoming you all to the 38th European PVSEC. Well, PV has come a long way since the very beginning in 1954 with the silicon photovoltaic cell at the Bell Labs. Even after years of development, PV was seen as a niche technology for remote regions, a technology that was highly dependent on the leftovers of the microelectronics industry. Those who have been working in PV know about this well. But we kept working because we had a vision, a passion that kept us on track. And we watched the learning curve evolution, prices coming down, efficiencies increasing. And today, when we look back on the road we have made, it's amazing. We see that our predecessors had the ambition and they had the passion and worked really hard to accomplish what they have accomplished. So we can say that we are here together because we stand on the shoulders of giants that opened the way for us. And now these are the days where solar cells reach efficiencies only seen in dreams. These are the days where PV is acknowledged as the cheapest form of electricity production. PV plant solar auctions achieve remarkable low prices for the electricity production, as we have seen, for example, in those launched by the Portuguese government. And some of them already include associated batteries and no subsidies at all. These are the days where PV systems are installed everywhere, in the fields, in buildings, in residential houses, in lakes, in floating photovoltaics, and also in agriculture application. So PV is everywhere. And so, in fact, are the EU PVSEC participants, like you, coming from all over the world and joining us here. So let me again welcome you. You know why you are here. We are ambitious and we have the passion for PV as our predecessors did. And now we also have an added motivation, a challenge that is bigger than each one of us. Climate change is the biggest challenge our generation is facing. And we know PV is a key player to contribute to the transition into a sustainable society. PV can dramatically change the quality of life of people in remote areas. But we now know that also PV has a huge importance in developing and developed countries. PV is a driver for change, and we are ready to take PV into the terawatt era. We have prepared an exciting program that addresses all dimensions of photovoltaics. Besides oral and poster sessions, we prepared 3 groups of plenary talks, one on devices in evolution, pushing the efficiency limits and broadening the technology portfolio that we had earlier this morning, and you can still see the recordings of it. We will have a second one on industry and applications, PV going everywhere. That will be on Wednesday, and a third one on Friday on sustainability and social acceptance, preparing for the terawatt era. And also, for the first time in the EU PVSEC, we will have a series of topic panel discussions on important issues of current PV development. Please also take a look at the parallel events going on through the week. We will have this morning, also just after these opening addresses, we will have this morning a moderated panel discussion around the idea of PV manufacturing coming back to Europe, which is, of course, very indeed. So please stay tuned. Unfortunately, we cannot meet physically as we wanted, and we know that being able to communicate directly with our colleagues and friends is something that is very important in a conference. But the platform on which the EU PVSEC is built will enable the participants to engage in discussions with the colleagues via the network capabilities of the platform. As last year, the sessions will be recorded and can be seen later. And don't forget that during breaks, you also have the chat rooms to arrange virtual meetings with your colleagues. Don't forget also that during oral and poster sessions, you can interact with the presenters. In the panel discussions that I mentioned, delegates can also participate in polls and send questions to the panelists. So please do so. You have here the chance to interact directly with the people on stage. I hope you will enjoy the conference, and at the end of the week, be glad to say, I was there, I saw it happening, I attended the 38th EU PVSEC. Thank you for being here. So let me introduce now the next speaker. After his PhD in political science at the London School of Economics, João Galamba worked in the private sector. He became a member of the Portuguese Parliament in 2009. He served at the 21st Constitutional Government as Secretary of State for Energy, and is currently Deputy Minister and Secretary of State for Energy at the 22nd Constitutional Government. And is also a big fan of photovoltaics, I know. So, Mr. João Galamba, the floor is yours.
Yeah, good morning to everybody attending. I would like to thank the organization for this invitation, and Professor João Serra in particular, the General Chair at the EU PVSEC 2021. In order to reverse the underdevelopment of solar PV in Portugal, it has to be said that Portugal, although is one of the countries in Europe with the highest potential for solar PV, the current installed capacity in Portugal is quite low, in percentage terms of its weight on the entire power mix in Portugal when compared to the rest of the European countries. Just for you to have an idea, we have a lower percentage than in the UK or Belgium, not countries famous for its solar potential. But in order to reverse the underdevelopment of solar PV in Portugal, the government in 2019 enacted several changes to the energy sector legislation, and we are further improving it as we speak. And we've done auctions in Portugal. In Portugal, the possibility to obtain a grid connection, which is the most scarce resource in the power sector, at least in Portugal for sure, it's 3 options. We have bilateral agreements with grid operators where there is no grid capacity available, and it falls upon the project's promoters, the grid investment costs. We have centralized auctions to tender existing or approved grid connection points resulting from the grid planning execution for renewable energy power plants. And then we have the regular requests for grid connections. The existing grid connections, although the 2 most important ones are the auctions and the bilateral agreements. Under the bilateral agreements, a total of 14 solar PV projects were approved by the TSO. These projects go from the north to the south of Portugal in the total of 3.5 gigawatts to be built in the next 5 years. The first solar auction in 2019 had 2 competing remuneration options, a fixed tariff price or a fixed contribution to the Portuguese power system. And the winning option will be the one that maximizes the value accrued to the SEN. SEN means Sistema Elétrico Nacional, it's the Portuguese national power system. 1,292 megawatts were awarded, and the average tariff was 20.4 euros per megawatt hour, with a total estimated gains for the Portuguese consumers of 600 million over a 15-year period. Of course, all these values change considerably with the current high prices. We estimated 2 months ago what was the present value of the auction prices 2 months ago, and it went up from 600, calculated at the time of the auction, to 1.2 billion euros. And now with prices still going up, this value, of course, increases. This just shows how apt the design of the auction in 2019 was. The solar auction included the creation by the government of a licensing monitoring committee for the auction solar power plants, composed of all the entities involved in licensing procedures to support in the matters that pertain to the state the auction's obligations fulfillment, namely the licensing deadlines. Last year's solar auction was again a resounding success, with Portugal setting a new world record for the lowest solar tariff price, recently undercut by Saudi Arabia. This auction awarded a little bit less than 670 megawatts, 75% of it at storage option, around 483 megawatts, and the remaining capacity in the fixed contribution, 177 megawatts, and in the contract for differences, 10 megawatts with a fixed price. The 12 batches that were auctioned were awarded to 6 different companies, half of which were not present in the Portuguese electricity generation market. In the storage option, 8 slots were awarded in the fixed contribution 4 batches and a single lot in the contract for differences. The total estimated gains for the Portuguese electricity consumers are around 560 million euros. In the same with the 2019 auction, these benefits will increase considerably with the current wholesale price levels. Heading to the fixed annual payment, the winners in the storage option will have to insure the power system against price spikes in the wholesale electricity market, hence giving the Portuguese consumers an additional revenue. The power system will also have, with the new solar plants with storage, an additional new storage capacity of a minimum 100 megawatts, which will contribute to absorb surplus renewable electricity in the grid, giving more needed flexibility to the system. The only lot in the second auction that was awarded in the contract for differences option was the lowest solar tariff in the world, 11.14 euros per megawatt hour, until last April, when Portugal was dethroned by Saudi Arabia. A loss that we don't regret, because it's not supposed that Portugal competes with countries such as Saudi Arabia, which have much more sun than we do. We have a lot, but they have more. Going forward, the government plans to expand the frontiers of solar PV deployment in the next solar auctions, which are already being planned. We will announce them this month, considering all suggestions and lessons learned from the first two. The next tenders will have new implementation possibilities, namely floating solar PV in dam reservoirs. We will make all regarding the reservoirs that we will auction, and the projected capacities will be announced this month. This is an important challenge on the technical side, but at the same time, the promoters will gain an important risk mitigation on the land availability and the costs that come with it. Considering the questions around the availability of land sites for conventional solar PV power plants, the rents that will be paid for the water surfaces to be auctioned will have a long-term predictable evolution, which, added to the water masses survey, will give a considerable upside for the developers of floating solar PV. The number of reservoirs to be put to tender will be announced during this month, as I said, and in the next 4 years, above 400 megawatts of floating solar PV will be auctioned. There will be 2 options available for each batch, as in the 2020 solar auction, CFD, or fixed payment to the power system, and the 2 remuneration options will be valid for 15 years. Developers will bid simultaneously for the grid injection capacity and the concession of the water surface. At the same time, we are reviewing the self-consumption legal framework, which also promotes the rollout of more solar PV on rooftop homes, as well as commercial and industrial installations. If I sum up what we're currently doing in Portugal, is we are trying to speed up as much as we can all solar PV installations, small, medium, large, on land, on dams, on rooftops, on parking lots, on everything. We need as much solar as we can, and it's our view that the best response that we can give to current high prices in the markets is to speed up the deployment of renewables, and in particular solar PV, which is by far the technology which is less developed in Portugal, although the one with the highest potential. And I'll stop here. Thank you.
Thank you, Mr. Galamba, for the government perspective of Portugal. We, of course, look forward to seeing it being in place, and also as a Portuguese is for me a huge thing to see happening in our country that has so much light. So we will continue this opening address, and our next speaker is Andreas Beth from Fraunhofer ISE. Professor Andreas Beth is director of the Fraunhofer Institute for Solar Energy Systems, ISE, in Freiburg, Germany, and is professor of solar energy materials and technologies in the Faculty of Mathematics and Physics, University of Freiburg. From 2007 until 2016, he was Division Director of Materials, Solar Cells and Technology. And from 2009 until 2016, he was Deputy Director of the Institute. So let me also take the opportunity to send our greetings and of all the community to the Fraunhofer ISE for celebrating 40 years of research dedicated not only to PV, but also to the energy transition as a whole. Let me say also that Andreas' presentation will serve as a teaser for the moderated panel discussion that will follow. Dear Andreas, the floor is yours.
So, good morning, everybody. Dear friends of photovoltaics, thank you, Jairo, for this very nice introduction from my person. And I'm really pleased to have here the opportunity to give an opening address for this European conference, where we all come together to speed up and to work further on photovoltaics. So I brought some slides with me. And I think we hopefully all agree photovoltaic technology has been a success story and it will be a success story. And what I want to share in this opening address with you is I want to share my thoughts about narratives for PV and how we handle that. The second important point is, and this is a part related, that it will be a success story also in the future. I think we all agreed, and we have heard that from Ms. Simpson, but also from Mr. Galamba, that without PV, we'll have no success to overcome our climate challenge. And this is becoming more and more urgent. And this is now also accepted worldwide. We are happy that US is back and fight that we can obtain the goals from the climate agreement in Paris. We all know that the 1.5 increase worldwide temperature will be pretty tough to achieve, but we have to do our best. And that means for PV, we have huge upcoming markets. It's incredible. We had in the past already growing markets, but we will see that it's much more coming. And that brings me also to the point I'm working for some years already to push that we will have also manufacturing in Europe again. So now, let's see. So to present the success story in the past, I mean, we all know this curve, price learning curve, where we sketch the module prices, not the cost, the prices, versus the cumulative production. And we see that we had over the past 40 years, more than a price drop of 25% by doubling our capacity. What is also here is the years given. So when I stepped in photovoltaics, this was 1985, so we had a price in the range of 20 euros per watt peak. Look where we are today. We can discuss, but we are around 20, 25 euro cents per watt peak. So it's a success story. We don't need to explain that. So coming to my thoughts about narratives for PV. In the early phase, I would say we did not have really a narrative. It was simply R&D phase to bring down the cost, to increase the efficiencies. That is still motivating us today. And the very first application was basically only remote. But then, after the 1,000 roof programs, the first industrialization phase, starting with the feed-in tariff established in Germany and spread over the world, starting in 2000, we had something around, and I put here a kind of what I say PV narrative was an important part in the 2010 years. That was a narrative that we would achieve with our cost grid parity. And that includes also a little bit, and then we don't see any hurdles for PV to grow further. But we all know that was not true. And it's in pretty much the same time where we have the narrative that PV is too expensive and it will never make it. I brought here this quote, which is quite popular, at least in German, from Mr. Grossman, at that time the COE of the RWE in 2012, where he says, PV, this form of energy generation in Germany makes as much sense as growing pineapple in Alaska. And we all know this quote was fairly wrong. We know that PV today is the cheapest energy provided in Germany, and it will go even lower in the future. So I think that shows that sometimes we have to be strong enough and we have to follow that point. So today, I would say PV is cheap. For me, it's no more a narrative, it's a fact. But we have to take this narrative. We have to tell it to others. Still, if we are in discussion, some people are not fully aware. Even so, I think most of the politicians and stakeholders understood that. We have now also another new narrative, and it was mentioned already several times also in the opening presentation, and I would call that PV everywhere. Because some of the counter narrative is PV needs too much areas. And I believe we have to say something against that, and this is simply PV narrative, PV everywhere. And to visualize that a little bit, I look first to an application of a motor, to the mobility. So this is a key element developed over many years, very efficient in a certain way, and used in different applications. So that means if we look at that and compare that to PV, in the heart of PV is a solar cell, well developed, will continuously developed as a motor, but it goes in much more different application as we have already heard today. For example, in agri-photovoltaics, in vehicle integrated photovoltaics, in building integrated photovoltaics, facade floating. Here another example, building integrated, and even in roads, and much more to come. Why? Because photovoltaics has become cheap. And again, this is very important. Here the prices are shown for modules, but if you look to the solar cell, it's even the lesser part in the module. And that means we can place photovoltaic cells everywhere. But on the other hand, because today PV is cheap, and I think it's an effort from production technologies, where also China supported, but a lot of research technology, bringing production technology in higher speed as well as higher efficiency, which was developed in Europe, in US, in other countries, not in Asia. Since it is cheap to know, I think we have new opportunities for local manufacturing. And I re-show here a slide which I presented also in the opening discussion during the European PV conference only 2 years ago, 2019. At that time, the people were not aware that the transport costs becoming a more and more important share. And I presented this slide, and I think it got some attention at that time, because at that time, nobody really thought to have really manufacturing here in Europe. We were fighting for that. But today we see actually that the transport costs are still rising, and the production costs will be in this range. So we have more than 10% for transport costs. And I think this is now well understood from all the community, which brings up that a local, and I say for us in Europe, European, but also true for US and India, a local production will be coming. And we believe, I believe, and I showed that already 3 years ago in my white paper for 10 gigawatt green fab, we have on the one hand the economic arguments as well as we have political arguments. First, the economic arguments. We can be cost competitive with Asian production, also because we have reduced costs, but we need also a certain volume. And this is possible because we have now a strong growing European market. I think this is very, very essential. Political arguments. We have seen in the last years a lot of publications and works to evaluate what are the real CO2 emissions during a PV production. And that could be also, by the way, a way to go to economic arguments if we set up around framework. So it's very important, and I put it on the political arguments, that we have the right frame, that we also consider the CO2 emissions during production. And something which has become important also due to the COVID crisis, I think it's much more understandable that we need an independency for important infrastructure and capability in production. I name this always, keep the technological sovereignty, which does not mean we want to protect our Europe or our economy. We have to be worldwide competitive, but it's another value to have the technological sovereignty. So why we need manufacturing in Europe? This is the landscape which my colleague Jochen Rentsch always tried to fill in all what is available in Europe. And what you can see at the end in the sum up table, we have capabilities in module, we have still a lot of capabilities in metallurgical grade and silica, polysilicon, but we are lacking actually from wafers via the cell here mainly up to a module. If you consider that our European market will be soon in the range of 30 gigawatt. And since we have this cost issue with transport, I think it's needed that we have really something here in Europe. And why it's coming now? I mean, I said this already 3 years ago, but there it was a little bit far away and people did not were convinced. But if you look what is today ongoing, we have some initiatives from the industry supported here, and I put that and say it's maybe not complete, but we are looking some initiatives for fully integrated production in Europe from wafer cell up to modules, and I name here some companies. We have some very active activities already established with Meyer Burger going from cell to module. We have activities in wafer, also with upcoming technologies like Next Wave, and some specific efforts in cells. So here I have to mention also very advanced technology of tandem structures of OPV, and module is ongoing. This is on the industry side. On the other side, we have supporting activities like the European Solar Cell Manufacturing Council, which has started an initiative to make use of the Recovery and Resilience Facility and Just Transition Funds. We try to establish an IPCEI, which will be a long way to go, but we have all worked together, and we have to work together, and this is done also with ESMC, Solar Power Europe, and ET platform, and we set up all together the manufacturing accelerator. So there is, if we are in line, I think we can be supported. And as a final slide here, I show here a study from the university in Finland and Energy Watch Group, which brought up what we need, and now we are again back not only in Europe, but worldwide. We need in the different areas gigawatt manufacturing. And if you consider here, we have at the end of 2020 in the field 700 gigawatts. To fulfill the 1.5 scenarios, they calculated, the Lund University, how many gigawatt installation we need. And if we bring that down to Europe, you see we need 15 gigawatt factories, each of a capacity of 60 gigawatt. And we need to install 8 terawatts till 2035. And there is also the numbers which you see in area, but as I mentioned before, PV will be everywhere, so we don't need 40 square kilometers as fresh areas. So to sum up somehow, I would say, let's do it. We have a challenge, we have a strong way to go to make 15 gigawatts in Europe and even more around the world. We have to develop still lower cost, higher efficiency, sustainability, recyclability. There are many efforts and many challenges which we face in our research community. And certainly the research is the base to bring it into industry. But as I mentioned, we have to work together to make it happen at the end, to save our Earth and to challenge the climate issue. That is why we come together, and this is my end. I wish that we have an intensive discussion among us and that we can contribute to set up PV manufacturing as well as to challenge the climate. Thank you very much, and I hope you will enjoy this exciting conference and the exciting program.
Thank you, Andres, for this exciting perspective on PV manufacturing accelerator, and under the motto PV is coming on. Well, we have one question from the audience, and I will read it to you from Klaus Jager from Helmholtz-Zentrum Berlin. It says, some critics say, while the LCOE might be cheap, that is not true because of the strongly varying production, and you should at the system it should aim at the system cost, which usually is not defined. How to react to these critics?
Yeah, I would say I agree with this discussion, but we have to find our narratives for PV. And for me, it's very important. I mentioned that PV will be an important part of our change for our energy system, but it's not only PV. And it has to be very clear that we need also storage. And I think for me, the next step is to combine batteries and PV as a next step. But we have to combine and align also with our colleagues. At the end, we have to solve a lot of issues, but we have to do our homework. And I think we have to come away from euros per watt peak, more to euros per kilowatt hours, to the performance in the field. And we will see that we have a lot of challenges there to solve if we go really to PV everywhere. But since the cell itself is cheap enough, I'm pretty sure we can tell that there are additional benefits if we implement PV everywhere.
Thank you, Andreas. So I think I don't see any more questions. So we will now have a short break while we prepare the stage for the moderated panel under the title, The Making of a Climate Neutral Continent, How to Recover and Boost a Sustainable European PV Production. So as you can see, Andreas' presentation was a teaser for this. And I also want to call your attention to the panelists. Henrik Hahn, member of the Greens EFA group in the European Parliament, Diederik Samson, head of cabinet of Frans Timmermans, executive vice president of the European Green Deal, European Commission, Joaquim Nunes de Almeida, European Commission, Director for Mobility and Energy Intensive Industries, DG GROW, European Commission. We also heard him this morning, João Galamba, Deputy Minister and Secretary of State for Energy, Portugal, Valburger Emmetsberger, CEO of Solar Power Europe, and also Andreas Beth from Fraunhofer ISE. The panel will be moderated by Radovan Kopacek from ISC Constance. So please stay in tune with us, and we will be back after the break. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture,
desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production but also large power plants, and combining with other technologies, it brings added value to cities, in buildings and to the electric mobility, but also in agriculture, desalination and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in remote parts of the globe. So we can say that PV is truly everywhere. The European Photovoltaic Energy Conference is a world reference when it comes to the latest PV developments. We have prepared an impressive program with oral and poster sessions, and also 3 groups of plenary sessions that will give you a broad vision of the latest PV development. And an innovation in the PVSEC will be panel discussions where participants can engage and interact with panelists on the hottest topics in PV. By attending the PVSEC, you will be able to get a flavor of what many people have worked for and dreamed for, the coming of the solar age. These are very exciting times, and PV is surfing the green wave into a bright future. I am looking forward to see you all in the European PVSEC 2021. We all know that the transition to a low-carbon society will not be possible.
Ladies and gentlemen, welcome back to the morning session of this 38th European PVSEC. So we had this exciting presentation about PV coming home, and we are all looking forward for the panel discussion that will follow under the title, The Making of Climate Neutral Continent, How to Recover and Boost a Sustainable European PV Production. You already know the participants and the panelists. Don't forget you can send questions and also participate in the polls. And I hand over to the moderator of the panel, Radovan Kopeček from ISC Constance. Radovan, the floor is yours.
Thank you very much, Joao, for this very inspiring opening so far. And yes, I hope that it will continue like this. So welcome everyone to this opening panel discussion with the title, The Making of Climate Neutral Continent, How to Recover and Boost a Sustainable European PV Production. I simply call it PV's Coming Home. How can we all assist? And I'm honored to moderate this panel discussion, if it's because it's a great mix of politics, members of the European Commission, R&D and industry, which I also warmly welcome, and I will introduce in a while. But let me first introduce the topic and also me. My name is Radovan Kopeček. I'm co-founder of ISC Constance. We are very much involved in technology transfer in new technologies, but here I am in my role as a representative of EUREC, which has the goal to connect R&D institutes and support innovations for the renewable market. And we are also involved in educating people and lobbying for photovoltaics. And let me also congratulate Ulrike Jahn for the Becquerel Prize, because Europe, it's not known only for, let's say, innovations and new solar cell devices, but also for quality. So that's also very important that this prize goes now to Ulrike. And thank you, Andreas, for the very motivating overview. And so let me introduce today's topic in 3 facts. Of course, we all know, and we already discussed this, that PV is the new king of energy markets. And this has been already discussed, that we are reaching 1 cent per kilowatt hour. And but the second thing is much more important, and maybe not everybody knows, that the demand is larger than the market can offer. So photovoltaics in the 3-4 years completely changed, and so the bottleneck of today's production is polysilicon at the moment, but in the future it can be also solar cells and modules. So I would say it's a no-brainer that we have to move to local production and more or less help China with the energy transition that where we all have ambitious plans. So as Joao already said, that the audience can put their questions into question and answer, but now we also would like to ask your opinion, and I ask the organizers, please put up the poll. And so the thing is that PV is coming home, and we ask you, what do you think will be the solar cell production capacity in future? So can the audience see the poll? Will it be 0 to 1 giga? Will it be 2 to 5 gigawatt? 6 to 20 or 21 to 50 or more? And yes, I don't see the poll at the moment, but I hope that you are using it. Good, so let me first introduce then the panelists. We have Henrike Hahn, who is a member of the European Parliament and part of Greens and European Free Alliance Group, and is a committee member of Industry Research and Energy. Then we have Dietrich Samson, and he's in the European Commission, head of cabinet of Franz Timmermans, and executive vice president for European Green Deal. Then we have Joachim Núñez de Almeida, who is also from the European Commission, and where he is the director for mobility and energy intensive industries. Then we already heard presentation from João Galamba, who is a Deputy Minister and Secretary of State for Energy and Minister of Portugal. And then we have Walburga Hemmetsberger, who is the CEO of Solar Power Europe. And in the last presentation, you saw Professor Andreas Bett, who is the Director of Fraunhofer ISE. So this is our board, and now the poll is coming up. So let me first describe this, what is in the poll. So many people believe that we will have more than today. So we will have about 8% 0 to 1 gigawatt, which is the case today, because we have about 600-700 megawatt, as Andreas has shown. So most of people believe we will have 2 to 5, but many also believe we will have 21 to 50. So it's an interesting result. I would expect a Gauss curve, but so there are many people who are expecting a lot, and there are many people that are, let's say, in the 2 to 5 gigawatt region. So let's see what you will say at the end of our discussion today. So let me turn now to the panelists, and first of all to Mrs. Hahn. And so the question is, PV is coming home. How can you assist with this? Please, Mrs. Hahn.
Thank you very much for the nice invitation. I'm very happy to be here today, and thank you, Mr. Kopicek, for the friendly introduction. So as we all know, renewable energies, and particularly the solar energy, are a key to achieve our European climate targets and the goals of the Green Deal, which is in the center of European politics at the moment. However, in Germany and also in my home region, Bavaria, that I represent in the parliament, the solar industry and thus the energy transformation is still not being supported enough by the government, also by the Bavarian government, but the German government in itself. And this contradicts, of course, the huge potential of renewables that we have. And if we want to meet our Paris climate goals, at least, we need to raise our ambitions and implement concrete measures. We, that means European Union, in cooperation with the member states, with the governments, the local governments, economy, and the citizens, of course. And we are afraid that the updated EU target of renewable energy shares of 40% until 2030 will not be enough to reach a highly efficient and fully renewable-based economy, means 100% by 2040, which as studies have shown is what we need to aim for to reduce global warming to 1.5 degrees. So first of all, we need a higher EU target, at least 50% until 2030, which can then be broken down in binding and strong national targets. Such strong national targets include making solar panels compulsory on new buildings, public and commercial buildings, as a first step before modernizing old roofs and extending the standard to the existing stock. Additionally, we also need solar installations on land. We therefore want to promote the expansion, for example, above parking lots, next to highways, in railways, or on post-mining areas in Europe. Agri-photovoltaic systems, for example, electricity production and agricultural use on a single site, can also make a potential contribution to climate protection, which is important to mention. So what's also important is that a huge part towards the transformation of our energy system can also come from citizens, and we Greens therefore have to make it easier for them to invest themselves and of course also to benefit from use cheap, extensive power. A massive expansion of the European PV system market also requires resilient and sustainable supply chain supported by a strong research and innovation, and the high ambition must also be reflected in the EU budget. I work currently as Green Shadow in Section 3 at the moment. Therefore, I fight for more funding for programs such as Horizon Europe, because via these programs we can ensure financing, innovative research, and a stable rollout of sustainable energy on EU level. And one point I would like to add to all of this is that with all these goals and measures, we shouldn't forget the side effects and long-term implications that come with the expansion of the solar industry. A study by the EAA has recently highlighted not only the substantial requirements of resources that will be needed, but also the large volume of waste that will be generated by the industry, waste which includes rare earth elements as well as other valuable materials such as steel, copper, and glass. And here we have to ensure that we apply principles of a circular economy, for example, by introducing measures such as stronger eco-design requirements and material-specific recycling targets to sustain and underpin the sustainability of renewable energy. To come to an end, we, the Greens, EFA, welcome that the Commission has endorsed the European solar initiatives into its updated industrial strategy, but we need to raise our ambition. We still have the chance for Europe to take the lead in renewable energy technologies and lead the way into a sustainable future, and a truly green industrial strategy can both revitalize the economy and contribute to achieve the greenhouse gas reduction targets, and let's take this chance. Thank you very much.
Okay, thank you very much, Mrs. Hahn, for this very complete picture, so many informations here. And now I turn to Mr. Samson. So could you please comment what those?
Yes, the question is what can we do? And well, I consider we for the moment as the European Commission. First of all, and that was already said in the introduction and also by the first speaker, we are going to ramp up demand big time. If you look at the targets of the Green Deal and specifically the Fit for 55 legislative package, and more specifically the Renewable Energy Directive, you can see that the amount of installed solar PV will amount to, triple in the next 6 to 7 years, and triple again in the decade after that, which is an enormous amount. And you could indeed, as Radovan himself said, consider, let's help the Chinese a little with producing all those PV cells. Because I can see, and this whole conference is basically hovering about that dreadful thought that we lost out on cells and modules to the Chinese, which is a fact of life. We lost out loads of production to the Chinese. We lost socks and T-shirts, more high-tech stuff like iPhones. They're all produced over there. And yes, we could long for lasting times and think, oh, we have to have that back, and we will have some of that back. But I do think our better strategy is to go beyond this production and do what Europe can do best and what we've always done best in the past, which is be better, be more innovative, be more creative, and invent new technologies and new production that can be done over here. And there's obviously two fields that I want to point out for this, and those two fields will be supported by the European Commission as much as we can. First of all, it's the innovative wafer technologies, perovskite, it's heterojunction cells. We shouldn't rely on the old technology to power Europe and power the world as we know it right now. It's becoming awfully cheap, so it's very attractive to keep making it, but we can do better. Perovskite has many more advantages than just being cheaper in the end. It's also more environmentally friendly. And the same goes for heterojunction cells because they're much more efficient. But there's more to it, because the new solar module will not be a module and that will be bolted onto something. No, the new PV will be into the materials that we use. And so Europe should be at the forefront of developing next generation solar PV, which will be in our building materials, in our cars, and on the sea. And those three areas are exactly the areas that I think Europe has an enormous potential to be the next front runner and to be the main production hub. It requires creativity, it requires innovation, it requires cross-cutting developments over sectors, so the building sector together with the solar sector, and the same goes for the car sector together with the solar sector, and the same goes for the offshore, which has been very efficient in hooking up with wind. Our offshore industry should also hook up with our solar PV and vice versa. I encourage all of you to do that. And you will find the European Commission at your side in making this happen. Horizon, other funds, the Recovery and Resilience Facility, we stand ready to bring PV back home to Europe.
Thank you very much for this statement. We will need a little bit more than planned for the statements, but that doesn't matter because it's very interesting. So now I ask Mr. Almeida, please, what can you do?
What can we do? Well, we know that we have the fastest growing energy source globally and in the EU, I mean solar. There's a tripling of annual installed capacity required to meet the 2030 EU climate targets globally. The market is projected to increase 20-fold by 2030. We're talking about staggering multiplications here. And there are three perspectives on solar. First, deployment needs. We need rapid deployment required to meet the EU energy and climate goals. We need, secondly, manufacturing capacity. Manufacturing of solar panels as an industrial opportunity. And third, we need competitiveness. Opportunities for EU industries to commercialize and scale up innovative solutions for PVs. At present, in Europe, manufacturing is only one part of the solar value chain. Most jobs connected to solar are not in the manufacturing of solar panels, but in their installation and operation and maintenance, which is quite an interesting piece of information to me. Overall, it is estimated that the solar PV and solar thermal sectors accounted for 149,800 jobs in the EU in 2018. We understand that the manufacturing of solar panels is nowadays highly automated and constantly evolving with technology. Keeping a foot in the game would therefore be strategically important to maintain expertise and avoid dependencies. The setting and the projected exponential rise in market size give rise to new hopes of building a new solar manufacturing industry in Europe based on new solutions and technologies. In recent years, there have been initiatives by member states, such as France and Poland, in this direction. On the regulatory front, we are working on eco-design and energy labeling requirements for PV modules, inverters, and systems. And under consideration for eco-design, we've got minimum requirements on performance for inverters and material efficiency, together with an information requirement on the environmental footprint of the manufacturing phase of PV modules. Energy labels for PV modules and systems are being proposed, and we will discuss two potential draft regulations in a dedicated meeting with the Eco-Design Consultation Forum to be held in the coming months. To end, outside of the regulation, we're exploring industrial policy options for solar, including funding. For example, in 2021, a consortium of European solar companies, together with EIT, Ino Energy and Solar Europe, created the European Solar Initiative, which aims to scale up solar production to 20 gigawatts by 2025, generating 40 billion euro GDP and 400,000 direct and indirect jobs. Commissioners Breton and Simpson have had discussions with CEOs of the involved companies and participated in its launch event at the 2021 EU Industry Days. It has a pipeline of projects prepared to achieve the targets, but indicates the availability of financing as a major hurdle. Thank you very much for your attention.
So thank you very much for these statements. And now I turn to Mr. Galamba. You already had a nice presentation, but still, maybe you can tell us in 2 minutes, condensed, what is Portugal doing?
The European companies, considering the PV market conditions, and as was said, cannot compete on cost, thus on SIPON cost. Thus, the R&D and innovation efforts should be our main goal, and we should move all our resources to try to take advantage of one thing that we regard as key to developing new technologies and more advanced technologies, which is to take full advantage of the ecosystem that exists in Europe. So we believe that the speed of deployment, the necessity of increasing the efficiency of solar, its coupling with storage and wind, that we believe that it is an opportunity to do what was said in the previous presentations, not to try to do the same as the Chinese, but try to go beyond that and tackle the existing challenges, taking advantage of the momentum of solar in Europe. And we believe that Portugal is such a country. We, for example, we are finalizing a complete overhaul of our power law in Portugal, and we will include in that law some areas, dedicated areas for the deployment of new technologies, testing of new technologies with some favorable conditions for grid access and for licensing. So we will have like a green route for licensing the projects exactly for testing new technologies. And that's the way to do it. We have to go, the advantages of Europe are not doing the same cheaper, of course, but doing better differently. And we believe there is a huge opportunity for such a project or projects in Europe. That's it. Thank you.
Okay. Thank you very much for the statements. And now, Walburga, what is your company or your, what is Solar Power Europe doing to enhance PV production in Europe.
Thank you very much, Radwan, and thanks very much for the invitation. So what are we doing at Solar Power Europe? We're working very hard to further boost the solar PV market, first of all. So that's not just key to get us to a 1.5 degrees Celsius scenario, but also the basis for any manufacturing in Europe. And let me just take some of the very precious seconds I have here now in these 2 minutes to nevertheless shed a little bit more light on the growth. Some of you have already referred to the enormous growth we see in solar today, but we think that solar is still underestimated and there is still not enough ambition yet. And let me just explore quickly why I think that is still underestimated. So we installed almost 20 gigawatts last year in the middle of the pandemic. As of 2023, we will be exceeding the 30 gigawatt level. As of then, we will be growing and installing 30, 35, 40 gigawatt. We will almost double today's installed capacity by 2024 already, so up from 137 to 252. Do we see ambition? And we do not see, yes, we see some ambition. The European Commission just recently presented its Fit for 55 package with many good proposals, and the 40% renewables target is a good start for further negotiations. But let me come back to why I do think we are still underestimated. In the impact assessment for the Fit for 55 package, the maximum installed capacity of solar the European Commission is looking at is 380 gigawatt. According to our own forecasts, and that's what we see happening on the ground, we will surpass these numbers already by 2025, 2026. So what we need is be more realistic on what solar can do and how solar can contribute to decarbonizing our economies. We are advocating, and now I'm coming back on what we can do. We're advocating for a 45% renewables target going forward for 2030. And that would rather put us to 850, 900 gigawatt installed by 2030 than what we already see happening going forward if we would be landing on the 40% target, which would be more in the range of 660 gigawatts and for sure not 380 gigawatt. But now, what does this mean for Europe's industrial strategy, and how can I contribute? How can Solar Power Europe contribute? Apart from further boosting demand, what we need is a sizable manufacturing capacity, and we need it along the whole value chain. So already we have been doing a lot in order to get to this goal, which is we gathered the whole ecosystem together with partners in the Solar Manufacturing Accelerator, in the European Solar Initiative. Thanks very much, Joachim, for mentioning the success of the European Solar Initiative. What it needs is a value chain approach, together with the off-takers, which we're also bringing in as members of Solar Power Europe. We need to have the whole value chain behind this idea of reviving solar manufacturing in Europe. That was the success of the Battery Alliance, and we want to replicate that success. What else? We have already raised awareness for the need of having a thriving PV industry. The success we've seen already is that solar has been taken up in the industrial strategy of the European Commission, and many other reports are also finally mentioning the importance of having an industry in Europe. But looking into the future, what can we do to further support PV manufacturing in Europe is the regulatory framework going ahead will be key. We will be discussing sustainability more and more, eco-design, eco-labeling, recycling. And these are the topics where we are working together with the Solar Power Europe members to make this regulatory framework the best regulatory framework for PV manufacturing in Europe to thrive. Just to end with, and I hope I'm not exceeding by far, but we do think that this is a make or break moment we are looking at this point in time. So we will not have the window of opportunity be as wide open as it is today. And we absolutely need to take this advantage and bring a sizable PV manufacturing industry to Europe again in order to cover the demand we're looking at in Europe. Thank you very much.
Thank you very much, Walburga. And now, Andreas, what is Fraunhofer doing or R&D doing for that?
Yes, thank you, Rado. I want first to make a statement, which I think is important coming from R&D, but you know that I'm also board member in ESMC because I started to found that. I think we can say in Europe, we are still leading in R&D with advanced technologies. If you look into the lab where we attained efficiency world records on lab cells. So this is a clear fact. However, if we are missing industry, we cannot transfer that. This is a part of innovation. And since we are closely linked in R&D also to machine makers, not only to cell makers, that was a very essential part in Europe during the last years, but we lose more and more also this part. That is why I insist to look on the whole supply chain, which means also equipment manufacturer, glass manufacturing, everything. We have, if I account the employment rates only for a fully automated cell manufacturing line, that's fairly low. But if we want to have innovations, we have also to put the employments in the machinery makers. And that is why it's so important that we have manufacturing in Europe. And here, Mr. Sampson, I would disagree with you. We are very, very good placed in terms of what I just said in a laboratory with new technologies, tandems, and so on. But in my opinion, we can compete with existing technology because PERC technology was mainly developed in Europe. And we compete also here. What is essential to do that is the market, and we have heard that this will happen. I'm absolutely convinced that. But to compete really on economic level, we need to have production also in tens of gigawatt scale, not talking about 1 or 4 or 5 gigawatts. We made a study with VDMA, and it's clearly an output that we need to have 10 gigawatts and more along the value chain. And I think that is what we need, also support from the governments, from politicians, to give the finance and resources to get started quickly. If we would rely and wait another 2 or 3 or 4 years, the market will grow so fast. And we see already in Asia a lot of investment. So we will lose more ground, and we have to put more money and larger installation in capacity in the future, as if we start now and compete on an economic way. So for me, it's very important that we start quickly with the technology available. The industry will select the technology. They will do the risk analysis, and there are different industry on the way. There are really good examples as Oxford PV going for tandem structures, Meyer Burger for heterojunctions. But with Greenland, for example, we are also considering to go with PERC. And I think it's true that all these high efficiency technologies will have a chance, but it's also important not only to talk about cell, but also on material side. So where the wafers come from. And I think this is one point I really stress repeatedly, because a lot of people don't only talk about cell. That's not all. Let's also talk about glass manufacturing, everything around that, a real economy on PV technology. And I think we are well placed. And the final sentence related to the pool, I mean, why it's not so distributed? Because we all know to build up a 10 gigawatt manufacturing is not from one day to another. It needs some time. That is why we need to start now. And there are certainly hesitance that we cannot do that because financing is not available. But I'm looking optimistic in the future. PV was always underestimated. If we look back what means cost reduction, also improving efficiencies, and I'm sure it's also underestimated what we can really deliver in terms of manufacturing. But we need a suitable framework, and that has to be delivered by the politicians, and that we work together, all together along the whole value chain. That's important, that we as a community work from materials up to full installation, whatever the installation looks like.
Yeah, thank you very much, Andreas. You made a very important point that we have to start now to set up PV production. And maybe I stay as the first question with you, because you mentioned Greenland. So Fraunhofer ISE is involved in there, and you mentioned you are building on, let's say, the working horse on technology. What will be needed to be successful with PERC in Europe? And you said it's possible. I also believe so. But what will you need? Is it like will you need finances for setting up? Is this the major bottleneck? Or to be sustainable, will you need support from the market that you can sell modules? And my question also targets the importance of bankability. How can, let's say, a newcomer from the beginning on sell the modules?
I mean, I think it's a good question. And that is why I mentioned every company has to make its own business model, where they come from. And then they have to somehow de-risk. Because on the one hand, you have the CapEx costs for the investments, but you have the running costs. And this is important to sell immediately your product. Your production line has to high throughput, that you have less losses, and all this takes money. So, and I think it's dependent on the company where they start. There are different solutions. And this is a fortunate thing for us, because we do not need only one company, and we should not focus on one company. We should focus on several companies doing tens of gigawatts. That's what I say, because the market is available. Even if you have 3 companies doing 10 gigawatts production, we still need to import from China, because the market will grow fast enough. So to say honestly, it's not easy to answer your question. You have to look into the details of all issues to bring up a company. In my personal opinion, I see look good of opportunities if you have some background already with heterojunction solar cells, as Meyer Burger, for example, has. Bring it with you. If you want to start, you can go, and I would say we can also learn from Chinese companies. In the early days, they bought equipment with well-functioning products. We still can do a high-efficiency PERC. Then you can sell it. It's maybe less risk in terms of bankability. I mean, I try to introduce CPV technology, and now I know the burden of new technology. Even if it's very convincing and also proving, the banks are very hesitant. So that means to bring up manufacturing, you need financing. We need to de-risk the financing, and I think that is also a part of the politicians. They can help us with different measures, could be local, and I think this is why some of the production technology or production facilities started in areas where are some supports available. And I think it's needed to get started. But I'm also deeply convinced that we shouldn't ask for continuous support. We must be competitive on the world market, and we will be.
Very good. So the message is clear. We have to do it now, and even with PERC. So innovations are great for the future, but PERC will be also needed in Europe. So maybe I go now to Mr. Galamba. I think installations these days, there's a huge pull from applications, but this session is also about production, PV production in Europe. And I think Greenland has plans to set up a big vertical integrated production 5 giga in Sevilla, which is close to Portugal. Do you have plans in Portugal to go or to support PV production as well?
Well, we have a small factory in the south of Portugal, but they will produce at low volumes, mainly for self-consumption, for industry and for domestic and industry. Our main solar company in Portugal adapted their technology. They used concentrated solar, and they've adapted their technology to and they've evolved to basically produce a technology that has solar with an electrolyzer embedded. They've just bought a factory. Those are the only solar-related projects regarding production of technology and equipment that we have in Portugal. But regarding the switch from solar to hydrogen, the Portuguese company is called Fusion Fuel. They used to be called Mag Power. It was when the solar PV costs went down, most of the companies in Europe went bankrupt. This company held on for a few years, and they had time to adapt their technology to electrolyzers. And we're currently quite excited with this. They have one factory, they just bought another one. They are massively expanding their production of this particular technology, which is not solar PV, but it is a story of a company that started more than 10 years ago in the solar industry. They had the technological advantage, but not the market conditions to compete with the Chinese, but they adapted their technology, which has very, very high efficiency, much higher than solar PV, and they are now very well positioned to take advantage of the existing hydrogen projects all around in Europe and all around the world, exactly because of their technological advantage and the existing costs. Just for you to have an idea, they can produce hydrogen today in Portugal at a little bit below 2 euros per kilo, which is the European goal for 2030. They do it now. And in Australia, with the existing solar conditions, they can produce today at 1.5. This is an example of a company with a technological edge that was able to found its marketplace in the current conditions. But going back to your original question, regarding solar PV, the only project we have is a small-scale project that tenders mainly to domestic users. But we are, of course, open to projects such as that. Just for you to have an idea of the existing pace of solar installations and licensing in Portugal, our regulator, ERS, just published 10 days ago an estimate that they believe that Portugal can achieve its goals for 2030 with the existing licenses already issued or on the verge of being issued. We can speed up the goals of 2030 for 2025. So our goals was to multiply by 10 solar PV, going back that Portugal has a high potential but very low installed capacity. And we are going well above our initial plan. And according to the regulators, we can achieve our goals 5 years early. And I think this tells a lot regarding the current pace of solar in Europe. The huge demand everywhere. Well, I have more knowledge of Portugal for obvious reasons, but the huge demand, and I believe that demand drives supply. So to reaffirm what I said before, I think we have the conditions to have solar projects in Europe. But that's up to the promoters of such projects to present the projects and then to identify the existing barriers that might inhibit their deployment. Thank you.
Yes. Thank you very much for this statement. So, Mrs. Hahn, you said that the Green Party, of course, is always more ambitious than the others, and you plan to have 50% renewables in 2030. And what do you think will be the portion of, let's say, PV produced in Europe by that time? Do you think that will be a big portion of that, or will we have to buy Chinese modules then, or?
Yeah, thank you very much for these interesting questions and remarks. I think, of course, if you look at the market for the past 10 years, photovoltaic electricity generation has been the fastest growing power generation source worldwide. Despite the COVID-19 pandemic, the overall investment in solar energy have increased by 12% to 125 billion. So this is, of course, something we can be very optimistic with. And the number of European countries installing more than 1 gigawatt annually has increased to 18 in 2020. Germany was the largest market in Europe, but that's just a side fact to mention. And however, despite this growth, we are far from reaching the full potential of the European PV manufacturing industry. There is, however, rich potential in Europe for the development of a strong solar industry. Photovoltaics currently covers only 3% of the total EU electricity demand, with an estimated potential of 15% by 2030. So we can be a lot more ambitious than we are at the moment. And photovoltaic is one of the most cost-effective energy technologies, which is why solar manufacturing should play a key role in the EU's industrial strategy, as I mentioned before. So I think we are on the same side when we see that there's an optimistic possibility for growth, and the importance of solar energy will rise additionally with our aim to decarbonize the industry. And this is, of course, something which is in the core of European politics at the moment, and it should be implemented in at various levels. And of course, when it comes to the framework and the EU targets on renewable energies, we need in general to rise our ambitions. As you has mentioned before, we Greens are especially ambitious, much more than other parties that we think, and we also can spell out on everyday life in our parliamentary work in Brussels.
Thank you very much. Mr. Almeida, how can energy labeling and eco-design create a better market for local production in Europe? And would it also make sense to put, let's say, energy or CO2 label on transportation costs?
I had to unmute myself. Well, the reply would be that Europe competes on quality rather than price in most segments. I mean, the story you see in most. I mean, I have an overview of many industrial sectors, and you often have a situation where the story is like, we were technologically ahead, but then the Chinese came with their lower prices and they managed to penetrate the market. We were out of business, and basically this is all about, this is possibly a general message I would like to make, of generating a more enlightened demand in Europe, in the sense of having a more longer term view, which would be, on the one hand, the public sector probably pushing for green procurement and for using the potential of existing procurement law to buy as much upgraded green products as possible. And in the private sector, to instill in the private sector a sense that it's in their long-term interest to not be dependent on short-term cheap imports from certain third countries. So the bet would be that the more you upgrade the market, the more you make the market, the product market, more demanding by eco-design and eco-labeling, the more you benefit Europe. Now, of course, who knows if the rest of the world at a certain time can become as expensive, as sophisticated and as quality-oriented as the rest of Europe. But in a short-term basis, in principle, the more you upgrade your product markets, the more you benefit European production.
Okay, thank you very much. Mr. Samson, you were telling about innovations, but Asbeth was responding that we need to act now to set up production with already existing technologies. What do you think will be, let's say, the share of technologies in future in Europe regarding innovation and let's say, the working horse of photovoltaic? Is it possible to compete with China, you believe?
Well, I'm not the expert on that, so I certainly concur with the Fraunhofer Institute if they say that we can also compete on with the existing technology in Europe, provided that our production is at a large scale, in the order of magnitude of 10 gigawatt or even more. We would certainly applaud initiatives of that scale and of that form. But I do think, and that was the gist of my message, that we also need to look beyond that, because we also have an issue with installing all those panels in Europe. Europe is a demanding society. You have to want it really bad in order to get something. And the European population is more and more worried about the landscape, the biodiversity, the issues that go with large-scale solar production as we see it growing right now. I see still a lot of potential of that, but looking beyond there and looking at the targets that we have, we need to integrate PV in our built environment. So in our buildings, literally, but also in our cars. And as I said, we need to look beyond the land towards the sea where the space is abundant. And that's where creativity, innovation, development, and large-scale production go hand in hand. So let's do both of them. So let's start in the short term, indeed, encourage, support large-scale production of the current technology, but at the same time, look beyond the coming decade towards the future and to develop those new innovative technologies.
Okay, thank you very much. And my last question before we come to the questions of the audience is to Walburga. So what is the major request of the companies that are talking to you? Of course, they are looking for budget to set up their production, but are there already some concerns to be sustainable with their production, or is it, let's say, the first hurdle they want to take now to set up PV production?
Thanks very much for that question. I would like to emphasize one thing that Andreas said earlier, because that's one of the main challenges we see is to de-risk financing. So this is very much also, again, a call to the European Commission and to also member states, Mr. Galamba, to really help these projects to de-risk their financing with support in order to get started, in order to scale up, in order to develop a globally competitive industry. But this scaling up really needs financing and the de-risking of financing. But then these companies also, to go forward, also need support, which is needed for many other sectors as well of the industry here in Europe, which is favorable conditions to do business. And that starts with competitive electricity prices, which you need for the production, which, for example, has to do with taxes, which has to do with levies. If you see electricity prices going up today in Europe, in many countries, this is because we still have too many fossils in our system. So that's yet another call for gearing up on bringing renewables to the ground in order to have these competitive electricity prices needed by these companies. And then I would still like to touch upon one point that Joachim mentioned, which is quality, and I would like to boil it down more to sustainability, because we are already highly sustainable in Europe, and that's our main competitive advantage, I would say, due to a cleaner energy mix, tout court. What we need is to further boost that framework, further boost sustainability, to give this competitive advantage to our industry. That is, for example, the CO2 content of products, value products, which are low when it comes to their CO2 content. We've been pushing and advocating for member states to allow CO2 criteria in tenders, for example, in order to provide that competitive advantage. We need to also increase the transparency vis-a-vis the end consumers. The end consumer does not know how reliable, how efficient, how performant PV is. So we need to do that, and the Commission is already working on it when it comes to energy labeling. But we really need to have this transparency as soon as possible. Supply chain transparency is another topic we at Solar Power Europe are also very hard working on tools in order to have more transparency in the supply chain. And then one big topic which is coming up and where we can also seize a competitive advantage for our industry is the whole topic of recycling. That is something which will be very important for our industry going forward, and where, with the European products, we could also have a competitive advantage going forward.
Thank you very much, Walburga, for speaking for the industry, what is required. So before we turn now to the questions from the audience, and I read them already, and there's one important topic which I will discuss later. We would like to put on the poll again for the audience, that they can poll what they believe will be the production capacity in 2025 in Europe, and maybe we will get a Gaussian curve. Then hopefully more towards large production. Okay, now turning to the questions of the audience, and there are also, let's say, questions, but also statements. And one of the statements is, why do we have to be better than China, and why not to produce low-cost modules in Europe? And relating question is also, why not, let's say, going with Chinese producers in Europe? And there will be a discussion in the opening of the industry forum later on, where ICO, the largest solar cell producer in China, has plans to start production in Europe and helps us with, let's say, stimulating the supply chain. So that will be the case. And so the question is, do we invite even Chinese producers to Europe to help us with mass production? Because we are very innovative. The Chinese are, of course, also very innovative, but Chinese are much better in mass production. And so first, I would like to discuss the poll. Yes, very nice, a Gaussian curve. So people believe most in 6 to 20 gigawatt production in Europe, and I think this will be needed to at least cover 30 to 40% of European needs. So let me turn as the last question first to Mr. Galamba, Chinese production in Portugal. You said that you invite consortia to present some projects. Will that be possible, or is Portugal ready for a big Chinese producer? I think, Mr. Galamba, you are unmute. If you would like to mute yourself or comment, or is there somebody else?
Sorry, can you repeat the question? I had a phone call, sorry.
Okay, sorry. So the question is, if a big Chinese producer like ICO or Trina, Longi would have big plans to start production in Portugal, would that be possible?
I'll invert the question. It would be impossible to stop such an investment. So Portugal welcomes all investments in its country. We had, I think there is no interest if there are Chinese companies willing to set up production projects in Portugal. it would be difficult for two reasons. It is a relevant project. Second, what would be the basis to reject such a project in Portugal? I don't, unless it violated a particular law or rule, but that would be it, and I see no reasons for such a thing to exist. So Portugal sees as positive all investments related with renewables, no matter where they come from. Of course, if there would be a technological project with an involvement of Portuguese research institutions, that would be different, but for different reasons. It would be different because Portugal would be involved from the start in such a project, and of course, if such was the case, we would be more interested in that project, not because it was Portuguese, Chinese, Belgium, but because we were involved in it from the start. But that's it.
Okay, thank you very much. Is there somebody else who would like to comment on this? Should we accept help from Chinese producers? Maybe Mrs. Han?
Yes. Yeah, that's a very interesting aspect. Thank you very much for that question and that comment. I think, of course, it's a part of the green industry strategy that we want to support the European economy to become or to remain sustainable, resilient, and competitive, of course, right? On the other hand, for the European Green Deal to be successful, the EU will need to work with its partners to build resilient supply chains for low carbon technologies and to develop standards for sustainable economy. That was what we discussed before. And here in between, we have to follow our path. And of course, from the European perspective, we have to concentrate on what we can do on at the European side. Also we as politicians, what we can do to support the European players in that regard. And of course, it's a good idea the EU could adapt its taxonomy for sustainable activities, a catalog to help investors to differentiate environmental friendly activities from polluting investments for use in other jurisdictions, including China, for example, right? So we have lots of ideas here, and there is a need for cooperation. On the other hand, there is a competition situation we also have to take into account, and it's also a strategic question, right, to be stable here and to have stable supply chains. So it's a very interesting question we have to discuss in the future even more, I think. Thanks.
Yes, thank you very much. So now it's time to end this very interesting discussion. And yeah, it was interesting for me because innovations are extremely important, but of course we have to start now. And there are many activities that are starting now or are already in place with Meyer Burger, NL, but there are more and more companies coming to produce in Europe. There will be an industry forum after this opening in 1 hour, I believe. And so we welcome you also to this opening of the industry forum. And yes, the statement from the audience was also that we do not have to be, let's say, better than China in terms of efficiency. So they believe we can start also now, even with the assistance of Chinese companies that plan to go to Europe and produce, like ICO did the first step. And PV is coming home. So hopefully we will see 10 to 30 gigawatt in 2025. Thank you very much.
Thank you, Radovan, for moderating this interesting panel. And with this, we have come to the end of this inspiring morning. And I hope that you were able to feel the exciting things that are happening regarding PV development. So I invite you to stay with us and enjoy the conference. We will restart at 13:30 with the afternoon program. So enjoy lunch if it's that the case for those that are in Europe. For the others will be breakfast or supper. So see you after lunch. Bye.
We all know that the transition to a low-carbon society will not be possible without a major shift to renewables. With the lowest levelized cost of electricity as acknowledged by the International Energy Agency, PV is at the forefront of new energy technologies to be a key player in this change. The solar resource on which PV is based is available all around the globe. PV benefits local energy production, but also large power plants, and combining with other technologies, it brings added value to cities, in buildings, and to the electric mobility, but also in agriculture, desalination, and hydrogen production. PV systems and modules bring dramatic changes to many people's lives, namely in